He's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9th centuries young with a lance that's...
Hello everyone, this is Deli. It's great to be here. So today I'm going to share a topic that we're quite familiar with, and I'd like to really bring up again regarding the TEs in Ethereum. So we'll actually go over some of the trusted execution concepts, and also we will dive into what kind of role TE gonna play in Ethereum and also in general in Web3. We're gonna reviving some of the original principles that Ethereum starts with. So by the way, I'm Deli. I'm the co-founder of Automata. We're actually building a verification layer for all kinds of trusted execution environments. In essence, actually, Ethereum has a lot of first principles when it was founded almost 8 years ago. Some of the principles include decentralizations, such as privacy, transparency, as well as trust minimizations. One of the more prominent one that coming out recently is actually censorship resistance. Ever since we started transition from proof of work to proof of stake, this has been a really important topic. And when MEV issue comes up, people are also discussing how those builders and also the players in PBS could play a part to prevent this kind of censorship from happening. Also, of course, there's tons of permissionless innovations going on, but still there are challenges as well. Also, they're just coming up along the way, scalability issues. That's why we have to take the L2 route to scale up Ethereum and also its ecosystem. And also privacy issue, people are using Tornado Cash for to hide the trace of the money, but there should be better tools that maybe more aligned with the compliance. And also fairness issue, of course, because there are chances right now, because of MEV issues, if your transaction might got treated differently from others if you're not tipping enough in your transactions. So then when it comes to the context of 2025, actually there has been quite a lot new primitives coming up. It's getting mature over the last year. We've seen a lot of rollups using zero-knowledge stacks. Also, we've seen projects trying to create MPC protocols, FH protocols as well. Of course, we are actually building a trusted execution environment. We are trying to use this kind of a hardware-based security to make Ethereum better. So one of the principles we are aware of is actually, although this kind of attack is still hasn't been adopted by the mainstream, but it's still it's something that we'd like to be more practical with. We'd love to see new applications coming up. Also later on we will review a few that already exist in Ethereum ecosystem. So actually, what is TE, our trusted execution environment? So TE is actually an isolated region in the hardwares that helps you to isolate your the code and data from other operating environment. For example, if you use Intel SGX, it helps you isolate your applications from even the operating system so that nobody, including the OS, including the operator of the node, can see what's going on inside your program, essentially. Of course, there are other types of TEs as well. For example, recently, NVIDIA also introduced TE into their H100 or H200 GPU, which makes it capable of running LM inference privately. We will also touch on this topic later on. Essentially, TE provides several very useful guarantees. One of them is actually confidentiality. because by nature it actually isolates the execution from the normal mode, so nobody can really like see the code that's being executed. Also, the memory regions are isolated as well, so this is really like a private enclave that only like approved users can access. Of course, it will be like one also important component called remote attestation. This is actually essential to verify all the claims that we have. For example, if I can present a proof that's showing that I'm actually running the machine, also I'm actually running the piece of code that you're expecting. So this is going to be some attestation that you can verify even remotely. Of course, right now we are seeing that most of the modern hardwares are actually capable of running this kind of special mode. You can see this kind of tag in like some of the cloud computing stacks, as well as your even like local machines, local devices, including your phones or even your laptops. So if we look at the broader picture, like what's TE looking like in Ethereum today, there are actually very good examples and also applications running in production. First of all, I'd like to also give a shout out to Flashbots, because they've been really like exploring the the frontiers of using TE to solve some of the MEV issues. I think lately they just brought this entire builder net in production, which consists of like builders that are entirely running in TEs. It gives some guaranteeing that you can really decentralize block building and also provide the guarantee that the transaction won't be reviewed until it's finally executed. Also, there has been development in the rollup space using TE as well. I think throughout the whole last year, we've seen many people, many rollups, especially ZK rollups, taking a step on like using TE for additional proving. Essentially, they're just running all the L2 blocks, L2 transactions inside the TE environment that essentially just emulate the transactions, but generate kind of a correctness proof to double check or whatever result that ZK circuit has generated. This is mostly used for like preventing like a single point of failure, because as we know, ZK circuit might still have some kind of unknown issues which could potentially jeopardize all the assets on rollups. Of course, we've also seen Flashbots develop this rollup boost framework that helps reduce block time and also provide verifiable priority ordering on networks like Unichain, which is a rollup network, OP stack based, created by Uniswap. Also lately, WorldCoin has launched WorldChain, which tries to prioritize the block space for humans. I think they are also using the rollup rules that are created by Flashbots. As you can see, many rollups has actually adopted this approach, which means TE has been used in the rollup space to secure at least millions of dollars values on chain. So this is, maybe I can extend a little bit on like how multi-prover really works in TE. Essentially, you're gonna have different types of proof system that you can make use of to make sure when one of the proof system has issue, there will always be like replacement. Of course, you can also run multiple proof system in parallel, so that you, when the in the end, you can really see maybe a committee of like different proofs and make a decision out of it. So it actually really greatly like reduce the single point of failure of any rollups and also improve kind of the trustworthiness a lot. Also, I'd like to continue other examples as well. I think we've seen new kind of development like from WorldCoin. They're actually building their newly created anonymous MPC service to help like prove the humanity of like people. Basically, they are scanning the iris code. They are getting the iris code from their like ops. Eventually, they will try to decide if this is one of the new code that they haven't seen before in their database. So what they're doing is they're actually running this database across like a MPC protocol, which requires a TE setup, because you'd like to have this kind of thing to prevent any collusion attacks, because this was kind of a known issue in the any of the MPC protocol. And of course, we have seen projects building in the composability space. Like they are trying to use TE to make fast confirmations, create real-time proofs as well. Lately, I think Eigenlayer has also mentioned that they are building autonomous verifiable services, which can also make use of TE coprocessors to kind of scale up the computations, to provide service for rollups, as well as for the AI agents as well. So if you like to compare TE with other technologies that we have seen in the previous slides, there are actually good sides and also bad sides. But I think we have to really understand what are the kind of the best fit for this kind of applications. I think one of the really good strengths is TE is really performant. Compared to running applications in the normal environment, TE actually doesn't add a lot of overhead. When it comes to using maybe ZK or MPC protocols, it's actually significantly more expensive to use. Not even to mention that there's cost in the proof generation as well as proof verifications. But on TE, it's actually very to verify the attestations is also very affordable on chain. But we have to also understand that there are limitations too. For example, if you are using hardwares, you can't really circumvent this issue, which is you have to trust the manufacturers, such as Intel or AMD. So this is one of the things that has been kind of the blocking some of the usage in blockchain, because if you really want to build a secure protocol, chances are you'd really try to remove any dependency on centralized parties. But if your trust model can accept this kind of a setup, I think this is actually an acceptable way to go. So actually, to mitigate some of the issues that people have brought up about TE, there has been quite a lot of different defenses. For example, at least you can start rotating your keys to prevent to prevent some of the side channel attacks, because when the times come that the keys are extracted, maybe the keys already expired, so it's kind of bypass this kind of attack vectors. Of course, you can avoid storing long-term secrets in your TE, because I think we all have consensus that maybe one day TE gonna break. It's better to stay on the safe side. So even if it's broken one day, if your secret is not the long-term, it's a informal key, you are still gonna be on the safe side, because all you need to do is just revoke the key and continue. Also, there are other mitigations you can do, like reproducible build, or even open sourcing your code to really let people verify all your claims in the attestations. Right, and next I'd like to also discuss actually a real-world usage of TE, but it's actually coming from the kind of the traditional Web2 world, which is Apple. They have been using TE to create their private cloud compute technology, which essentially helps you to run more powerful and advanced LLM models on the cloud, but still preserve privacy. How did they do this? They actually use specialized operating systems running on their own Apple Silicon hardwares. Essentially, they're creating their own server specs so that they can run this kind of TE-capable hardwares. Then they are trying to process the data between your personal device and the cloud node, so that only the your device or even you will know the data that you're sending over to the node running in their cloud. And of course, they have all the transparency logs that over there that you can verify all these kind of guarantees. So it's actually quite powerful, although some of the components are actually still closed sourced. But I think it's actually one of the kind of most complete TE cloud-based TE applications, which gives us a lot of inspirations when building similar solutions in the Web2 space or Web3 space. So when it comes to the TE acceleration, we've seen that there are many existing use cases, but we'd also like to explore some of the futuristic ones. For example, this is something that we're building. We're trying to create a verifiable and privacy-preserving RPC, so that when users visit the RPC nodes for blockchain data or even for LLM like response, their private information won't be collected, and also they will know that the data source is trustworthy. Of course, there are also like other really interesting use cases, such as building a private DeFi protocol, or even a fair markets to settle the transactions. And also, if you are really keen to like exploring the AI agent space, there are teams also building like verifiable AI agents or autonomous AI agent that are fully running in TE, including the agent framework as well as the AI models, which provide a really strong guarantee in terms of the privacy of the data and also the verifiability of the model. I'd like to also address some of the actual concerns again. If you have issues with like hardware trust and have concerns on like centralizations of the major maybe the manufacturers, there are a couple of ways to actually to avoid this. One of the things is at least you could use multiple different TE vendors. There are already like a lot of technologies out there. If you use two of them, you will at least have a better guarantee, because it's hard to really break all of the like maybe two of the like TE technologies out there. Also, you could start like really embarrassing like open source TE solutions. There has been research effort on like creating an open enclave, like maybe for example the Keystone projects like in the RISC-V space. Also, as a developer, you could really think about create like more fail-safe design. So when like even in the most extreme cases, when like all the TEs break, you still have kind of a fallback that will not harm users. For example, you could still have ZK as one of the fallback solution. It's just a little bit slow, but still nothing will eventually break, because it's kind of the it's gonna save all the like the data over there. Also, like people have been talking about like security vulnerabilities. Also, there are new reports coming up in especially maybe like Intel hardwares and AMD hardwares. So for those, I think as long as we can patch those firmwares as soon as possible, also like have really good secure SecOps. Eventually, these are all like non-issues to like running a like TE environments, because essentially these are some of the challenges we have to overcome. Of course, to really like convince people that you're really running good hardwares and also the like codes in the code bases, you have to also produce like attestations properly. Really trying to verify those attestations even on chain or off chain to convince other people. Also, you could like you could try different like offerings from different cloud providers, which provide additional redundancy. You could also have like new hardware support like coming up from NVIDIA GPU, which helps you to run private LLMs in hardwares. So actually, there has been also quite a lot of resources right now. If you want to get involved in like TEs in Ethereum, especially, you could really like go to some of the forums over there. It's actually contributed by most of the TE projects that I've listed on the screen. Right. So essentially, TAC is more like a social campaign right now, because we know that there's pushbacks coming from the community, coming from the researchers, but we're really trying to come together and trying to show that this is really a more practical approach when it comes to some of the issues that we're facing, no matter it's the scalability issue, no matter it's the privacy issue. Also, like we've seen that recently, all the AI-based compute, it really requires a lot of computation powers, which might not be a good fit for other solutions. But at least we've seen the effort from like all the hardware vendors to try to make it happen, so that we can really have a more safe environment for your like AI workloads. Yeah, so we would hope that in 2025, we will see more applications coming up like using TEs, and we'd like to see more cross-stack applications as well. So maybe using ZK with TE, or maybe using MPC with TEs. These are really interesting solutions that we look forward to. Right. I think we are coming to the end of the talk. If you have any like things you'd like to know, please follow us on the socials or get connected with us. If we have, maybe we have 1 minute over here. If we have questions from audience, please raise your hand. Okay, if not, I think that will be the everything for today. Thanks, everyone. It's really glad to be here.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, Ethernight whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange rules over slow motion doom. Her shield's a disco wall, fracturing legs, grass, crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. To do with for do with for do with do with do with do 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 you ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. keys are burning, ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna biddle it there. Some TradFi bro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pay let the city on sports and chains. We pay let the city with regen brains. We pay let the city on sports and chains. No rug pulls, just pure on chain. If you faded, just stay seated. The Etherverse will leave you heated. We don't need your legacy, cause regen memes are proof of brain. We let the city on sports and chains. We let the city with regen brains. We let the city on sports and chains. Rolling up and slapping chains. She's a Colorado comet in code forged steel. Wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, Ethernight whiz. Found her at a bullet hook, sucking down APIs. Armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning force. The bluff, the corn's grid, protocol can commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with the buffercorn's grid, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with do You ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess. Scales of justice ballast on a mempool express. Next bottleneck, I see mountain crush it.
And welcome. Today we are going to be talking about verifying, don't trust, DeSci's role in powering trustless innovation with blockchain. I'm Erin McGinnis, and I'm really excited to dive into what a lot of these different mechanisms that we might all be familiar with in Web3 and how that can be applied to the scientific sector. I guess laying some initial groundwork, across the board, we're seeing how Web3 is disrupting these very trust-based systems, maybe different legacy systems across finance, governance, media. These are a few examples of different brands we might know and love. Next up in this evolution of disrupting these trust-based legacy systems is science, in my opinion, and in the opinion of many others within the DeSci space. And this really is rooted in the issue that trust in science is broken, which I think a lot of people might not realize the full extent of this if they aren't deep within the scientific sector or exposed to it in different types of ways. This is one really renowned example of how trust in science is broken. So in 2006, as a society, we found the cure to Alzheimer's, which was incredible. Billions of dollars went down this path of, based on some different research, looking at some different proteins. And 20 years of entire researchers' careers and societal progress towards finding a cure and developing it further for Alzheimer's went down this pathway. Then just a couple years ago, we found out that this data was manipulated. This image, which is of a Western blot, was basically photoshopped. That set back the progress that we had supposedly made by 20 years. Imagine where we could be at today. Imagine the different people's lives it could have impacted. That's what I mean when trust in science is broken. And this is just one example. There are countless more. Other examples of how trust in society at large is broken are examples like this, a photoshopped image of the Pope. And this might do some harm within the religious sector, but at a large scale, this isn't costing people's lives. This isn't completely transforming the quality of their life. But science does, which is why this matters. And as we continue developing further into an era of AI, we'll see more and more examples like this, and examples like this within science as well. And with those developments, it will be harder to detect with even current mechanisms of addressing fraud within science to realize those manipulations of different data. And like we just discussed, that can result in setting back different fields by 20 years. Or that can mean the difference between life and death for countless people. Another example of this is within the vaccine space. So on the screen right now, this is a picture of COVID vaccines that have passed all of the manufacturing checkpoints. So this is up to quality standard right now, but there aren't really checks in place to determine, okay, at this type of kind of more critical, in-depth level, should this really be injected into people's bodies? And this might mean the difference between somebody getting life-altering side effects or the vaccine just not working for them or protecting them from different diseases. And some of the different mechanisms that Web3 can help enable in building these trustless systems can dive in at this level and give you the transparency to make the decision of, do you want to take this or not? It gives you the information you need to fully trust the different science, health, medicines you might be engaging with. And all of this really comes back to an underlying principle of, if it can be gamed, it will be gamed, especially if there are different economic incentives in place as well. A few different examples of this within the scientific sector of gaming science is across the board, starting at regular kind of consumer health type levels, all the way up to large biotech pharmaceutical companies, and also within the academic research space. Some examples are GSK. They had an acquisition that cost them $720 million. Just one deal. Post-acquisition, they found out a bunch of the data was manipulated. That's not useful for their organization, their different stakeholders, and ultimately they were they lost that money due to that data manipulation and the incentive to not be fully transparent. Within the Web3 space, there are a ton of different apps, such as StepIn, which was an example that gained a bit of popularity a couple of years ago. But even within StepIn, using some of these baseline Web3 mechanisms, there was a lot of gamification because people were incentivized to take additional steps or fake steps or automate different portions of it to receive those different economic rewards. So StepIn really doesn't have that place within the health kind of Web3 space anymore, unfortunately. Another example is within academic science, where we're finding fraud within science growing 10x over the past 10 years. And that's only what's being detected so far. There are a lot of really great examples of furthering this detection as well. But paired with that is also furthering the ability to be sneakier about it and manipulate data more effectively, ultimately doing more academic fraud. And this is incentivized because researchers rely on interesting results, flashy results, kind of like the image of the Pope. Doesn't necessarily mean it's true. And that's at the cost for all of us. At a baseline, this is really connected to the fact that there's this replication crisis going on right now, and 70% of scientific experiments cannot be replicated. And this is why we're still waiting for different discoveries and cures. When we're thinking about decentralizing science across the board, there's a fundamental challenge within this space that some of the other sectors that Web3 is able to really effectively address. It's a little bit more complicated in science. And that's due to the fact that a lot of science is based on hardware. It's based on people interacting with different lab equipment, different machines, to do these different experiments. So when we're thinking about what does a trustless system within science look like, it can't be purely digital, like the financial sector was able to get away with, or like media is able to get away with as well, to build out those trust systems within it. Within science, because it has such this core foundational layer in hardware, to build this trustless system, it also needs to be happening at that hardware level and through automation to be able to fully trust what's happening, removing some of those different variables at play. So what might that really look like? It can look like starting at that hardware integration level. From there, being able to cryptographically sign as that data is being created at that source level, having that proof be put on chain, and then allowing access to view that verification instantly for consumers or whoever that end user might be that is relying on this data being true. This is kind of high-level flow of what this might look like. And then from there, that can extend into a lot of other mechanisms, dApps, and other platforms. It's kind of the foundational layer. And in real life, this can look like integrating with a really wide range of different lab equipment or hardware devices, from PCR machines to looking at COVID vaccine purity levels with electron microscopes, EEG devices, and that can even extend into kind of the broader research domain with Web2 companies doing neuromarketing campaigns. And then also with bioreactors that citizen scientists might use, which is this entirely new layer and ecosystem that is able to be unlocked if we're able to trust one another and trust the data we each are producing. Doubling down on what this might enable or look like at scale is having an entirely verified bioreactor mainframe. And that can enable larger scales of data, especially open data, going into different data marketplaces, incentivizing contribution, building out more trustworthy AI or causal models, and having tokenization to be attributed to the people that are proving the work that they're doing, as well as other prediction markets, dApps. Everything we're able to see in the broader Web3 landscape can then be built off of this first trust layer within science. This is really what enables true decentralized science, this trust. And this layer is what can unlock what the future of science might be able to look like right now, and that we're already trending towards, this creator economy of science, the long tail of science, where biohackers or maker spaces or citizen scientist communities or individuals are able to participate at the same level that different Ivy labs are able to participate, with the same level of trust, credibility, and also the ability to build up reputation within this space, which is really the currency within science right now. Paired with this is the fact that hardware costs are coming down. So different devices and equipment that used to be too expensive for the average person to be able to engage with or produce science with, now they're able to just have it at their kitchen table. The bioreactor, EEG devices are great examples of this. Another trend that's happening right now is historically, R&D funding has been monopolized to a few different countries. Now, a wider set of countries are heavily investing in R&D and kind of capturing those different markets. However, they're still not always able to play at the same level of like financial success or economic success as certain regions. By coming up to the standard of using real truth tech and trust tech, they're now able to play at this global scale, unlocking more and more participation, and that's really where discoveries of the future will likely come from. Which, coming back to the beginning, if more and more people were able to participate in exploring, hey, is this Alzheimer's research really true? Maybe instead of it taking about 20 years, could have only taken 2 or a couple months to realize, hey, maybe this isn't the best path to spend billions of dollars going down. And maybe other people's lives would be transformed in the meantime, too. If any of this resonates with you, we would love for you to connect. The DeSci space is a growing ecosystem, and there's more and more opportunity to be able to participate at any level. It doesn't require different credentials or background. It just requires the ability or willingness to participate and the willingness to be transparent so trust can be exchanged throughout this entire system. My name is Erin McGinnis. You can find me on X or Telegram at just my name, as well as Causality Network, where we're working on helping to enable the entire DeSci landscape, as well as a traditional science space under this umbrella. There are a lot of other incredible projects systems within science can look like. Please reach out. It's going to be a really exciting future of discovery. Thank you.
Sunrise every day. Gals are voting, vibes She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, ether night whisk. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with a do with a do with do with do. You ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if you chains choking Ethernight whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks' backs. Alliance architect with a bluff acorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with do with do with do 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 do. You ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing while my coke's too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Bend it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifier's huffing, you're just a rat with his firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI. Get homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency so. Professor Waze got the future on spinball. Urgent notes dancing where the bottlenecks been. Professor Waze got the future on spinball. Plugging tomorrow with yesterday's RAM stays. Velcro.
All right, hello everybody. Thanks for coming to this talk. I'm Nikita. I'm the co-founder and CEO of Chain Patrol. And today I'll be talking to you about do-it-yourself brand protection for Web3 startups. So essentially, this is actually something our company does, but this is something all of you can do yourselves to help protect your users from impersonation, from phishing attacks, and from fake airdrops. Now, to start off, just last year, there was over 600 million lost due to impersonation and phishing attacks. Think about all the fake airdrops you see on Twitter, all the fake Google ads, scammers in your Discord. This is all something that's targeting your community. And so this is something that you need to be very much aware of. Whether you're a large project, a small project, scammers are targeting your community. They're impersonating your brand, they're cloning your website, they are making copies of your founders' profiles, reaching out to your users, to your community, and trying to trick them to go into a wallet-draining website. This is something that happens very commonly. I'm sure a lot of people here already got hit or know somebody that's gotten hit by one of these. But really what these scammers are going for is they're trying to steal your seed phrase, they're trying to get you to sign a malicious transaction, or otherwise install malware on your computer that then steals all your funds. Now, projects of all sizes are being targeted. What we're seeing here that it's not just like the really big ones, the big L2s, you know, the companies that everybody knows. It's even, we're seeing that even small projects with only maybe like 5K followers on Twitter, with just starting off with their basically building up their community, they're already getting targeted. They're getting clones of their Twitter account. They're getting clones of their of their users on Discord, and basically scammers are trying to target your users to steal funds from them. And so what can we do about this? Like, what can you, as somebody that's starting a new project or running a big community, what can you do to actually protect your users? So first step is track all of your digital assets. So before we can do all this stuff of how do we find the scammers, how do we get rid of them, how do we protect our users, you need to take an inventory of what is going on with your digital footprint. So you want to take a look at everything from your visuals, have a good sense of your brand kit, your obviously company name, your logos, all your brand colors. This is all going to be important for various forms of detection that you can run. Keep track of all of your high-profile people, like obviously the founders, but employees, ambassadors, also like any DevRels. This is especially important because DevRels get impersonated heavily in this space. Know what digital platforms you're heavily present on. For everybody in crypto, that's probably just like your domains and your Twitter profile, but also know that if you have a presence on like TikTok, YouTube, other places, scammers are all over these platforms impersonating your brand. And the last part is like any kind of like vendors you're working with, partners, somebody that you might have launched a campaign with. We, for example, have seen places where people are launching with Deform, and then the Deform is getting impersonated but targeting another brand, right? And so we've actually worked with them to help in this case as well. So now you've taken inventory of everything you have, all your brand kit, all of your official domains, keep track of your parked domains too. And now let's go into threat detection. So how can you find these impersonations before they hit your users? So to detect threats early, there's a couple of things as a crypto kind of startup you really want to focus on. You want to look at domains, your X account, and Google Ads. These are like the top three. There's also scammers in your Discord, but there's a little bit of a different solution for that. So for domains, you need to keep track of what are your official domains, what are all the X accounts. I highly recommend that if you can use the affiliated feature, make sure all of your team members are officially affiliated to your main account. This helps a lot with determining who's an impersonator or who is real. And then monitor Google Ads. Just basically go and search for your brand like a regular user. Search your own company's name on Twitter, search your founders' names on Twitter, search yourself on Google Search and other engines, and see what comes up. You might be surprised to see, hey, there's an ad here that's above my company name leading to a wallet draining website. And if you find this, okay, what we need to do now, you need to do something about this. So the core is really search for this like a regular user across platforms, and then there's some some advanced tools that I'm about to dive into that can take you a step further, being URL scan, DNS twist, and also IOK rules as well that we can look into. So the very first one, this one's like super simple to use, DNS twist. You put in your domain name, it finds all the kind of permutations that are kind of similar. Somebody replaces a letter, somebody adds some words, and basically somebody might try to like adjust how your domain is spelled. For example, here I just put in uniswap.org. It found me a bunch of these. This is just like the start of the scan. You can see there's like 3,400 results here. And it actually goes ahead and tries to find you like, is the site live? Where is it registered? It doesn't just like, you know, blindly just throw a bunch of letters and numbers in there. It actually tries to find things that are similar to your domain and do some basic checks of like, is there a response? Is there liveness? Saves you a lot of trouble. You can see some of these already coming up. And actually what I noticed was these are actually blocklisted by a lot of the major security providers out there, which is great. Then you want to look at URL scan next. URL scan, a bit more advanced. You need to learn how to use it, but it's also not that complicated. So basically, what it does is full scanning of domains. Tons of companies, from security companies to like individual brands, use this to find different. Basically, you can just put in there any website. It'll scan it, take a screenshot, grab all the code that's in the website, and kind of store it. And this is very useful because you can see what are the contents of the site. You don't actually have to navigate if you suspect there's malware there or some other issues. It can scan the site for you. And then when you scan a site, especially if you don't scan your own site, URL scan actually builds up a graph of visual similarity and of code similarity across all scans that it's run. So for example, here somebody's like scanning Netflix and actually finds all the websites that look like Netflix that have been scanned across this platform. And this is important for you because you don't have the time to go and search for all the different domains that might be similar to yours. And this is what scammers do a lot. They will often go ahead, they'll clone your entire website, host it on a new domain, add -airdrop in the name, and basically email it out to all your users. What this does is, if anybody scanned that domain, if anybody scans similar domains, anything that looks like your website will show up in these results. And this can be a very quick way of finding what is impersonating your site and trying to target your users. Now, this is like in terms of domains. So let's go into a bit of like X or Twitter detection. So in this case, there's just a couple of things you want to do, right? It's fairly simple things, but they can go a very long way. Just look for your brand name and then airdrop. Like Arbitrum airdrop, Optimism airdrop. These things happened way long ago, but there's still scams trying to impersonate these different orgs, right? And even if you're a small company, if there's any news around you of you might be doing a TGE or an airdrop or going to testnet, these are all events that are targeting your org. Start searching for this, even if there's rumors out there this might be happening, because the scammers act based on these rumors. So look for things like your brand name airdrop, your brand name claim. Look for the ticker symbols. If you have a coin or anything else, oftentimes the scammers will be like, oh, this like Stark, STRK like airdrop going on, and then that's what they will use to target your organization. Look for hashtags including your name and this kind of stuff. Very quick, like 10-20 minutes of search, and you can find a bunch of impersonations. We'll go into what to do about them in a moment. Last thing is, this is a big one, Google search and ads. I hope everybody, most people have ad blockers, but if you don't, and there's a lot of people who don't, you will get hit by these, right? And so basically, scammers can take out ads against your company. Somebody will search your company name, and the first result they see will be a scammer site. You go there, it looks exactly like your website, it drains the user's wallet. And so again, search for both the common terms like brand airdrop, brand login, claim, but also this is something not many people know is Google search actually has a very in-depth query language you can use. And so, for example, we've seen a lot of scammers use popular hosting sites to create thousands and thousands of fake pages. There's stuff like Webflow, Gitbook, Teachable. They get abused for this a lot. And so what you can do is to type something like here, we have this site.star.webflow.io, and then you can say in the title is your brand. And it's going to find all the Webflow sites that have your brand's name somewhere in the title. And this can help you actually automatically find all the impersonators if they're using all these platforms. The big ones to look out for are like Webflow, Gitbook, Teachable, and GoDaddy sites as well. Those get abused quite a bit. Yeah, so let's keep going. So, okay, so you found a bunch of scams. You found all these impersonators. Like, what do you do about this now? So, two things. First one, takedowns. This is where you need to go to the hosting provider and let them know, hey, like, this is impersonating me, get rid of this. If you have trademarks, this is ideal to have. Trademarks or any sort of like company like formation documents and just anything that can prove that you actually own this like brand is very, very helpful. A lot of hosting providers will just do it out of the bat. Other ones are more stringent, and other ones are you really got to push them to get them to take something down. But a lot of them are quite compliant. And so you can go to their hosting providers and use their abuse emails or their forums to take them down. And there's actually a very useful tool here, fish.report. You can actually go there. They have just a search where you can put in any website, and it'll let you know where is it being hosted and where to submit the abuse report. And so it makes all this stuff much simpler to do. Now, for block listing. So takedowns can take a while. So takedowns can take anywhere between 5 to 8 hours if it's like doing amazing, to like a week to a month, to potentially never if it's a non-compliant hosting provider or DNS registrar. And so this is where block listing comes in. This is something that exists in both the traditional Web 2 space, but it's also grown a lot in the Web 3 space as well, where essentially there's a bunch of different organizations, and we all collaborate together. There's us at Chain Patrol, there's SEAL, also known as the Security Alliance, there's the Phishing Attack built by MetaMask. We're actually all contributing to one major block list of malicious domains that goes out to all the major wallets out there, like MetaMask, Phantom, Coinbase Wallet, like a whole bunch of others. There's a block list that goes out all out there, and there's people on our team, there's people at MetaMask, there's people at SEAL that are all actively looking at these submissions for these domains. So you can go and basically report these. You can go on the ePhishing Detect repo. You can also just go to like chainpatrol.io/report. You have a scam link, paste it in there, we'll handle it for you, right? This is something that we do across the whole ecosystem, is basically just finding scams, reviewing them, getting them blocklisted, and ensuring 0 false positives. And so now, the wider block list is there's also Google Safe Browsing. Google Safe Browsing is embedded into Chrome, Edge, Firefox, all the major Safari and others, all the major browsers out there. This is harder to land on their block list. They do a lot more checking. It takes a bit longer, but you can report to them as well. They have a report site here, and then like when it lands on that block list, like nobody on the internet can access that site anymore. And that's great for protecting your users, because it's important to make sure that they know that, hey, this is a phishing site. There's going to be a big red warning on the site when you visit it, and it's going to help protect your users from these attacks. Here's an example of the warning you might see if you have MetaMask installed and you visit one of these sites on the block list. You'll just see that this website might be harmful, it's deceptive, you don't touch it. You can still proceed. We also have a process for disputing these. If any time, like there are very, very rare cases of false positives, you can report them to us as well. We within a couple of minutes will respond to you and get the site unblocked as well. That's a big part of this whole block listing solution, is that the goal is to stop scammers and not to impact legitimate projects in the space. And this is a coordination of SEAL and a whole bunch of teams across the ecosystem. So that's really the two main things that you can do immediately. You found a scam, you go take it down, and you get it blocklisted. Now, as you see this, once you've become a target, the scammers aren't going to be like, oh, well, one thing got taken down, we're done, we're moving on. Typically, if you have a lot of hype around your project or you have a quickly growing community, the scammers know that as well. They're very dialed into what projects have a lot of eyes on them, and they know that's perfectly the place for them to deploy their impersonations. So you need to monitor consistently. Again, URL scan, they actually have an alerts feature as well. Once you have a search query that you see shows you a lot of impersonations, you can actually set an alert for it. You'll get emails whenever there's something new pops up on that search, so you know that, hey, there's something for me to look at here. Create a sheet, just track these, have somewhere where you have even very basic, like just a list of the sites. Did you do a takedown? Did you blocklist it? Some of these hosting providers, they really require follow-ups for them to actually remove anything. And then understand the impact on your community. Just be aware, like, did somebody in your community get hit by these? Have a way for the community to connect to and basically like reach out and offer them help, offer them some guidance. There's us and Seal and others have lots of great guides on like what to do if you did get hit by one of these, how to secure your wallet if it's still in a securable state and you didn't give up your seed phrase. If you gave up your seed phrase, you're done. There's not really much that can be done outside of like maybe some freezing and recovery at that point. But there's things that we can do to help, right? And so monitor these attacks, understand the impact, and then see how you can help out your community. Part of this is building a clear source of truth. This is very important. A lot of projects do this, but I'm still constantly finding others that don't, is have places where your community can go to find the official links. Have it inserted into your docs, have your Discord have an official links channel right at the top that nobody can type in, right? Just some of these basic things will help a lot for users to double check and make sure that they're interacting with the right site. And then we've got so yeah, the dedicated channels, and also get your stuff allow listed. Actually, us and Seal and Efficient Tech and others, we all collaborate on kind of like a mega allow list of legitimate domains in the space. And this helps with catching scammers faster and verifying legitimate projects as well. This helps significantly with like all the security work that goes on behind the scenes in the crypto space. And the final thing is just involve your community, right? You're part of the solution, like you as the leader of a project, as the person building this, I think it's the responsibility of all the projects to like do something to protect their community, find these scams, help take them down. But your community members actually hate the scammers themselves, and they don't like them. They don't want them to thrive, and they want to get rid of them. So essentially, when like no one likes scammers and your community can help, you can create a scam report channel in your Discord, drive users there, let them know like, hey, like if you see a scam, just report it there, have it as part of like your Discord onboarding, and then have your mods monitoring that, and then have them trained on like, what do you do when a user does report a scam? What happens if I see a scam on Twitter? How do I take it down? If I see a fake domain, how do I blocklist it? Like have like just a process for what to do in this case, because a lot of times those reports come in and people don't really know what to do about them. And if you just make an easy flow for this, it becomes much more straightforward, and you'll see a lot less losses in your community. And there's lots of bots. There's like Wick. There's others that are great. There's like Sledgehammer. There's Hashbot, and our own Chain Patrol bot as well. They all serve a bit of a different focuses, but there's things that can gate scammers from entering your Discord, that can check for impersonations of your team members, your mods, and your admins. They do like comparisons on the profile pictures and the usernames. You can put certain words like, oh, you can't mention like an airdrop about us because we don't have an airdrop going on. And just some basic stuff like this will go a long way to prevent your users from getting scammed. Yeah, so that's essentially it. Thank you, everyone. I hope you learned something about how to keep your community safe. I think it's immensely important. We're going to have lots of people this year and the coming years coming that are completely fresh, and we need to protect them. The best way to grow crypto is to make people feel like they're safe, they can transact, and that there's really no, that they can feel safe in this new ecosystem. Thank you.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, Ethernight whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange rules over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bah crack.
My name is Michael Boyle. I'm a security researcher and auditor at Quantstamp, a Web3 security company. And today we're going to be talking about money Legos in 2025, securely integrating DeFi projects using AI. So why are we doing this talk? Or this is what we're going to cover today. First, we're going to talk about why we're doing this talk. We're going to talk about the current state of integration documentation. We're going to look at solutions to improve the current state of the integrations, and then as well as a proof of concept looking at using LLMs to help developers integrate into more protocols. So first things first, we need to cover DeFi composability. We can think of DeFi as a bunch of money Lego blocks where each aspect of DeFi can build on top of each other. So in this chart here, we have everything on top integrates with the thing beneath it. So if we go all the way to the bottom, we have an ERC20 token called YOLO, and then on top of that, we have oracles that then pull the price for this YOLO token. Then we have maybe liquid staking projects, which then use those oracles, and then maybe lending protocols on top of that, and yield aggregators on top of that, so on and so forth. And so as we go up the stack, we have more and more integrations, which means that we have more risks, more consequences, and more trust assumptions that we have to be careful about during the development process. So in this example, say the ERC20 token YOLO is pausable and upgradable. This would mean that every single one of those protocols above them needs to be able to account for the fact that their token might not be transferable at some point. It might be upgraded to do something else at some point. And because of that, they need to be proactive decisions that are made during the development process to be able to handle any situation which can happen for protocols that you are integrating with. So another example, say this oracle has an issue. Now it has a stale price. This could potentially affect everything that integrates with it above it. So in this case, everything on the left side of the chart, we're not going to have to worry about. It doesn't integrate with that directly, and so it's not an issue. But we can see that even one thing going wrong partway up the stack is still going to affect a bunch of protocols, and this needs to be handled correctly. So here we have an example of two protocols that in some ways, or where protocol 1 integrates with protocol 2. We're going to say that a user deposits into protocol 1, and then protocol 1 does some kind of yield aggregation and then deposits the user's funds into protocol 2. And then we'll say for some unknown reason, protocol 2 needs to pause. Maybe they found an issue and they needed to fix it, or something happened with protocol 2, which then creates an unrecoverable denial of service in protocol 1. So now from a user's perspective, they see that I deposited into protocol 1, which interacts with protocol 2. But either way, I can't access my funds out of Protocol 1 because of its integration with Protocol 2, and it didn't handle it correctly. So now not only is Protocol 1 going to be at fault for having a bug in their code, but Protocol 2 is also going to get some of the blame and have a reputation hit because people didn't correctly integrate with them. And so that's mostly what we're going to be looking at today, is how to make sure that that your DeFi money Lego has the proper considerations for how others should integrate with you. So obviously, we're coming back to a topic that grew rapidly in popularity in around 2020. So we want to come back to it for a few reasons. Mainly, we wanted to look at the use of AI and LLMs to help solve this problem. Also, security knowledge in general has just become more well-known. The space is more mature. And so the documentation has gotten a lot better. Yeah, and so since the ecosystem's upgraded, we want to come back to it and see if we can help out developers streamline this process even more and prevent integration issues going forward. So the first thing we did was we wanted to look at the current state of integration documentation. And so we have an example here where we're looking at a category of libraries. So these are low-level development tools that most Solidity developers have used at some point in their lives. We're looking at like Open Zeppelin libraries or the Solidity libraries. And we can see for both of them that they use documentation that is specific to developers that are going to be using these libraries. So they have warnings specific to some of the functions that they may use, and they indicate proper usage as well as common pitfalls that people might run into. And so these are very, very developer-oriented, but no user of DeFi protocols is going to be reading these. Next, we have oracles, which again are a bedrock foundation of many DeFi protocols. And we can look through all of these oracles, and we can see both user and dev-focused documentation, which is good because we want to see things where if they can be used by a user, it needs to have user-facing documentation, but we also need developer and security-focused documentation for any DeFi money Lego block. Finally, we looked at the documentation for another very common Lego brick, which would be lending protocols. So we looked at a few here like Aave, JustLend, Morpho. And our overall impression of these was that the developer docs were actually lacking. And we mostly see user-facing documentation, assuming that nothing is going to be built on top of these, which, as we've seen from many yield aggregators and swapping protocols and all kinds of stuff, it's just not the case. These lending protocols are used as a base for other projects and therefore should have security protocols and security considerations that are developer-facing and security-oriented to give developers the best chance to integrate with these protocols without having a hack. So just imagine that something that integrates with one of these lending protocols has an issue, and someone sees that their assets are technically sitting in Aave right now, but they're completely locked because the project that integrated with Aave didn't integrate correctly. Now the user is going to have a bad perception of not only the project that they deposited into, but also Aave. And so it's best practice for anything in DeFi to give integration recommendations at all levels. So we want to talk about the importance of composability guidelines and very specific use cases and how we want to have, like what do we want the documentation to look like when we're integrating with a project. So these are some of the main things that we came up with. We need to have an exhaustive and correct and actionable list as possible. We need to have every action that can be taken by a user or an integration. We need to have it listed. We need to have its security considerations. We need to know things like, is the contract going to be upgradable or paused? If someone integrates with your contract that is pausable or upgradable, there's a very good chance that if you ever actually do pause or upgrade the contract, that you're going to break integrations and could potentially ruin something else down the line. Basically, anything that you use as a configuration parameter that is controlled by admins, that is not controlled by a typical user, can change the interactions with integrations, and so therefore they need to be accounted for. Again, we need clear warnings, we need clear and common pitfalls recorded, and they need to be easily searchable and LLM friendly. So in this case, that means that we need sections that are very specifically user focused, very specifically security focused, and very specifically developer focused. So here's kind of a situation of how it would look like when an auditor needs to audit a protocol that has integrations. So in this example, we have both contracts A and B, and we can say that A and B both have different builders and different auditors. If contract B was built first and then contract A uses contract B, if I am an auditor for contract A, then I'm hoping that not only did auditor B do a good job, but I also need builder B to have good integration documentation so that I can quickly reference how contract A should be correctly integrating with contract B, and how my contract can avoid any of the common pitfalls that might have come up from integrating with contract B. I also, unfortunately, can't take auditor B's word for it, or even the documentation's word for it. So these are all just general guidelines to get things going, but at the end of the day, we also need to manually review the code of contract B in order to be certain that contract A is correctly integrating with anything beneath it. So now we're going to go into a proof of concept where we kind of talk about using LLMs to help generate some of these security checkpoint lists that we're looking at. So we're going to use a project that is a standard lending project, and it integrates with Chainlink as its oracle. We anonymize the contract. It is from one of our actual audits, but we wanted to keep everything private and anonymous. So the first part of this check was we used an LLM query with the public integrations checklist provided by Chainlink. So we're basically going to take the documentation straight from Chainlink, we're going to take the contract code that we've audited, and we're going to give them both to an LLM and see, can it give us security recommendations based off of just the documentation that Chainlink has. And then second, we're going to give our own internal auditing checklist and see how that does as well. So there's a lot going on here. I don't expect you to read this all. This is just kind of an overview of what we actually gave to the LLM as context so that it knows obviously what the project does and how it integrates with Chainlink, as well as some of its admin control or functionality that might affect integrations. So here's what our prompt actually looked like. We say that for the smart contract above, is there any violation of any of the practices described on this page? And then we have a link to the Chainlink documentation about using Chainlink oracles. So what we get back from this is actually pretty promising. We see that we get concerns about data freshness verification. We don't want any stale data coming from the Chainlink oracle, and so we need to manually validate that within the contract. We see that it brings up the issue of single oracle dependency. So any protocol that uses oracles and needs data at all times should probably have some kind of data availability where we're using multiple oracles. We look at price validation mechanisms. So sometimes when an oracle has stale or outdated prices, we could get something that is way off from what's expected, or it'll even return 0. And we need to correctly handle that situation so that we're not adversely affecting users. We also see that it points out that there are administrative controls which could affect how the oracle, how it's receiving information from the oracle, as well as decimal precision handling, since not all tokens and not all data that is sent on-chain is going to have the same number of decimals that we use on-chain to represent the data. So then our second case study here was to use internal checklists that we've developed. Since we have audited so many different protocols and seen so many different DeFi and Oracle integrations, we have plenty exhaustive lists of integrations, or for integrations like this. And so we use our background knowledge of all of our audits to create our own checklist for things that we would look at when a project is integrating with an Oracle. And we wanted to see how this compares to Chainlink's actual documentation. So again, we supplied our checklist along with the code, and this is what we got this time. We get more of a question-based answer where it's saying we need to, or it's asking, kind of repeating the questions that we're asking in the checklist and then trying to answer it for us. So we see it ask things like, is the Oracle data up to date? Is the Oracle single source a failure, like we talked about before? Is the Oracle price hard-coded? Is the price feed for a similar asset used to represent another asset, which could be similar to, say, the decimal issue? And then any other, or I guess the decimal issue is the next one, but any other considerations that are similar to the previous one. So our takeaway from this was that you kind of need both. You can't always rely on one protocol to give you a good enough security guidelines that you can just feed it into an LLM along with the contract and assume that you actually are going to have all of the information that you want to need for the audit. You also, your list, if you're an auditor, even if you've been doing it for a long time, is not always going to be completely specific to the protocol that you are auditing. So just because it has a chain link integration doesn't mean that it doesn't do something unique or different with it than you've seen in previous audits. So ultimately, we always recommend using both, and then of course a manual audit to cover in those gaps where you might have unique scenarios. So the conclusions are that we have DeFi security composability is an ecosystem level topic. We would love to see more protocols create composability guidelines that are security and auditing focused. And we want to reduce hacks. For many vendors, it's hard to find good security guidelines that are readily available and developer oriented. And I think a lot of protocols overlook the fact that they are adding to the DeFi money Lego stack. They're not necessarily going to be the last brick on the stack, even if they are at the time when they create it. So maybe right after you publish your protocol, your next step would be to consider how someone might integrate with your protocol or aggregate your protocol and create a best practices list for others to use in order to prevent your reputation from being on the line if someone integrates with your protocol incorrectly. These are some additional resources if you want to take a look. And thank you for listening. I think we have a few extra minutes if we have any questions. Looks like we have a question. I'm going to have to ask you to yell it at me, and then I'll repeat it. So that is an excellent question. He asked, how do we make sure that the LLM is not flawed? Obviously, LLMs, especially at this stage, are known to hallucinate. And so this is why we still have to recommend that you do a manual audit in conjunction with using the LLMs. It's going to give you a good baseline. It's going to give you guidelines to start off of. But ultimately, you are going to have to double check it and actually do the work yourself. It's just going to help, hopefully remind you and help kind of create the checklist to start. Anyone else? Guess not. Thank you.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if you chains choking Ethernight whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks' backs. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do-do with for do-do with for do-do with do with do-do-do-do-do-do. You ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Ships. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster type chump. Eyes everywhere, that's 3 bird phones. Haunteries whisper king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Head it up to the entropy. Lace cracked vaults like who's got the keys? Nullifiers huffing, you're just a rat with These firewall splinter to confetti bits. I'm curating leaps at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on P Island. Get homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency sub. Professor Waze got the future on spinball. Urgent notes dancing where the bottlenecks been. Professor Waze got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Velcro boots clicking.
Hello, everyone. I'm Christoph. I'm from AWS in the Web3 team. And what I'm going to talk about today is indexing blockchain data. You all know, of course, that blockchain has a lot of data on it. It's stored immutably there. It can never be deleted. But it's actually quite hard to access. So the question is, how can we use that data in our applications and then build on top of that? And that's what I'm going to talk about, specifically building your own indexing solutions. So let me just start out with this very simple architecture that you probably know of. You have a front end on the very left side, you have the blockchains on the very right. Then on the lower path, you have this transaction management, actually writing data to blockchain. Your users can use the front end to do stuff that creates a blockchain transaction that will be sent off to blockchain. Of course, you have some wallet interaction in there. I just put MetaMask there, or you can use AWS services for it to sign your transactions, and then they'll make it into blockchain. There is this other path on the top, querying data, which is the one that we are concerned with. Of course, your front end or whatever application you're building always needs the data. It needs to access the current blockchain data, the current state of things. So just imagine you're building a DeFi application. Of course, you want to know the current prices on the very DEXs that the tokens have. And there are various ways to get that information. Of course, the very simplest thing that you can do is just query the smart contract directly. And that's what you usually start out with. It's simple enough. You can just ask a smart contract, what is the current state of things? And then, of course, work with that data. However, you'll soon find out blockchains are, of course, not really meant for querying data. They're really good at storing data, and they're really good at securing that stored data. So we have all these proofs that data that sits on blockchain has never been tampered with, because we have, of course, the entire all the guarantees that blockchains gives, which is really good, but it's fairly hard to get the data. So if you're building an application that just needs the current state of things, that's easy enough. You can query a smart contract for its current state. However, once you want to do something like historical data, give me the prices half a year ago, it's, of course, the data is on blockchain, but it's almost impossible to query directly. Just because the way the blockchain store data, it becomes fairly hard to do. So we need something different, and that's what we're going to talk about. Just this query path, we want to optimize for that. We're not concerned about the transaction management down there, just about the querying things. Now there are really three solutions. The first one I've already hinted at. You can, of course, just query the smart contract directly. That's the easiest thing, and that's just what you can do immediately off the bat, if you will. And then we'll come to the more advanced solutions, either using existing indexes or indeed building your own indexer for the blockchain data. Just talking about the very first one, query smart contract directly. Very easy to implement. Here on the right side, you can see a token that wants to do an airdrop for based on the ownership of another token. So if you do have a BAYC, I think it was, yeah, BAYC token, then you can claim this other token that we've developed here. And of course, it's a fairly simple line in Solidity where you can query another smart contract and say, does this particular address have a token of a BAYC token here? It's simple to do, but again, it only really is useful for the current state of things. If you do want to do something like historical data or range queries or anything more sophisticated than just querying this single bit of data, then it's really out the window. You can't really use that. So we need something else for that. That's what we're going to talk about now. Using existing indexes. There are really two flavors to this. One is, of course, there are very many companies that actually have indexes that you can just use. And we at AWS are one of them. We actually do have a managed service that allows you to query data for the Ethereum and Bitcoin blockchain. And if that is what you need, say token ownership on either Bitcoin or Ethereum, then of course probably your very best bet is to use an existing indexer, because they have gone through all the heavy lifting, they have done the hard work for you, and normally they just provide you some sort of API that you can just query and have all the historical data and whatever they integrate. And there are a couple of them. So recommendation first, look if there are existing indexes. If there aren't, and there are very many cases where there aren't existing indexes, and in particular one of them is if you have custom events. So if you're only interested in something like token ownership, that's what most of the existing indexes support right there. So you can almost always query them. But of course, there are smart contracts that have custom events that are specific for these smart contracts. And most of the existing general purpose indexes, of course, don't cover them. They, of course, will see those events, but they won't decode them, so you don't have the data available. So that is one of the major use cases where you probably need to look somewhere else. The other second major use case is, of course, if your chain isn't supported. Not all indexers support all chains, and in particular, if you're looking for high throughput chains that have very small block times, something like, say, Base or so, 2-second block times, that's really a lot of data. Most of the existing indexes won't cover that. And if you're looking at something like Solana, it's even worse. Even fewer indexers cover that in a real-time fashion. There are many that cover the historical side of things, but not really real-time data. So using existing indexes is really good if you're in this standard event space, if you will. If you're looking for custom events, do something different. Build your own indexer based on an existing framework. This is what how the architecture will change then, of course. Instead of the front end on the left side polling our blockchain directly, instead we put this blockchain indexer in between. So the blockchain indexer does the heavy lifting for us. It queries the blockchain for whatever we want the indexer to query, and then provides this data in some sort of aggregated form, in some sort of custom schema for our front end. So the front end can do really simple queries only. It doesn't need to do all these complicated queries or aggregate different API calls or anything like it, because a blockchain indexer does that for us. Excuse me. One of the major, I'd say, frameworks for that is the Graph, of course. It's an open source framework. They have their own dedicated graph network that you can use to deploy your subgraphs to. But if you want to, you can also spin up your own graph node. This is what it would look like on AWS. And we do actually have, that's the QR code on the lower left there. We do have a CDK script that does it for you. So if you ever need your own particular graph node, you can just use that, and it's more or less a 3-line deployment or so, which would spin up this entire architecture for you, an ECS, Elastic Container Service, so a container management solution with various Docker containers, one the graph node, one an IPFS node, and then, of course, storage, RDS or database, and then EFS for the metadata and for backing up the IPFS node. The whole thing is then fronted by API gateway, so you have a simple enough interface to do the GraphQL queries that the graph node supports. If you're using the graph, the really nice thing about it is you really have control over everything you can possibly think of. For one, you run the node on your own, so you define which blockchain you want to index, and then you also define everything that this particular node needs to index. You define the schema, you define every single event that it tracks. You can even do smart contract calls if you want to, and then all put it into your own custom data schema. I've just drawn it on the left, these little boxes there, just a simple example where you would have a contract, and then that contract has a token, and then the token has owners, which are really, of course, blockchain accounts. So this particular subgraph would then map really subscribe to the blockchain for this particular smart contract and map all the transfer events that come into our custom data schema. And of course, if you have custom events that you want to track because you're building, I don't know, a DEX or so, something like that, then you would just integrate that. You define the data schema, you write the mapping itself. So the mapping from the events into your data schema is entirely under your control. And then you just let it do its thing, really spin it up. It indexes the blockchain from whatever block you want to start off with, even historical blocks, of course, and then provides that data in a nice, easy to query format, namely GraphQL. So it's fairly nice, but if who has ever worked with a graph, just a show of hands? Some have. You probably hated it. It's really, really slow. It's a very steep learning curve, very hard to get right. So it is there. It's really useful if you get the hang of it, but it does have some disadvantages. One of them, it is fairly slow. And that is because what it does is the graph node, if you just go back to the architecture here, what the graph node does, it queries the blockchain for new data. And of course, it uses the normal RPC calls that we have. And then, of course, it needs to do all the mapping. You need to get the mapping right, which is complicated in and of itself. So many things can go wrong with it. So we want to do something, something better, if you will. And that then would be, all right, we're not using an existing framework, we're just building the thing on our own. If I had this talk a year ago, this would have been my very first solution, and I would have highly discouraged to do that. And one of the things why this is really complicated is, of course, because blockchains have this thing called reorgs. So it can happen that a currently valid block in the blockchain, on the canonical blockchain, does become invalid because we have forks down the road and something like that. We have reorganizations of the blocks. And of course, your indexer needs to be aware of that. So there are many pitfalls that you can fall into. But very luckily, we have some really nice solutions, or at least approaches nowadays, that make this thing much easier. So what are the current problems with our existing solutions? One, of course, I've hinted at that. The indexer currently polls our blockchain via RPC. So it continuously polls data, calls the RPC for new blocks, for new transactions, new events, and so on, which makes it really, really slow, to be honest. If you go about, there is a sort of the canonical, if you will, Uniswap subgraph. If you try to deploy that on the graph, it takes about 3 months or so to actually index the entire Uniswap smart contract, because it's just a lot of data and it needs to do millions and millions of RPC calls to get all the data into the database. So that is one of the problems that we want to tackle. The other one is we have a fairly late transformation. The node processes all the data. It then sends it or gets polled by the indexer for the data, and then only the node, the indexer itself, transforms the data into whatever you want it to have. That is fairly late in the process. There could be an interesting idea of moving that closer to the node. And then the final one, transformation definition at compile time. With the graph, you define the structures that you want to have, you define the mapping, then you deploy the subgraph, it starts indexing. If you see that there was some kind of mistake in your mapping, you'll fix that mistake, you'll start from scratch. You need to re-index from scratch again, and again, if it's a large smart contract, that's going to take very, very long. So we can be thinking about putting that transformation layer somewhere closer to our actual indexer, so it doesn't happen at compile time, but rather at runtime. Now, going through each one of these, indexer polls via RPC. What you see here is the existing architecture. Front end polls the indexer blockchain indexer queries via RPC the blockchain nodes. What we'd rather have is instead the blockchain nodes, when they are processing new blocks, transactions, and all that, instead push the data into our indexer. So that would, of course, make it much simpler for the indexer to actually be aware of new data because it gets them continuously via the node. And then the front end can still pull the data from the blockchain indexer, or it could be some sort of push mechanism there too. But the main part that we are concerned about now is really the blockchain nodes pushing data into our indexer. Late transformation. Currently, the node processes the blocks, that's the upper blue box there, then pushes data or gets the data over to the indexer, and then only the indexer starts transforming the data. This is a highly recommended blog post. It's not by me, it's by Andrew Hong. Really highly recommended. That's the QR code down there. That's where this whole diagram comes from. And he makes the point saying there is this tendency of pushing transformation closer to the actual execution, to the node itself, which of course makes it probably much quicker and probably simpler to do because the node is, well, it's processing the transactions anyways. And then finally, transformation, definition, currently happening at compile time, so we need to re-index every single time. We'd rather want to pull that into our runtime. So while the indexer is running, we can push a new definition into it and would immediately pick it up and start indexing on that. So what does that look like? And this is, if you want to take home something, this is the slide to take home, because this is really all the approaches combined. For one, the first thing is blockchain nodes have done considerable advances during the last year or two or so, and in particular the Reth node came out. And the Reth node does one thing that is really, really useful. It gives you the ability to define so-called execution extensions that are directly compiled into the node itself. So what an execution extension does, it gets a block whenever it's processed by the node, and then it's up to you what to do with that data. And what we can do here, of course, is use the data, the new block data, and push it out to our sink, to our indexer in this case, to work on that. So that's what why Reth is in here. The Go Ethereum Geth client has something similar called live tracing, if I remember correctly. I haven't looked at that much. I've only looked at the execution extensions of Reth, which are really useful. Only caveat, they're written in Rust, so you need to know Rust to use them. And so now the Reth node pushes data into our indexer, and we restructure the indexer itself. And what we do here now is we're pushing the data into a Kafka queue, and then use that Kafka queue as our source for data for everything else. And of course, Kafka has this really nice ability that we're pushing data into it, and we can have various consumers independently use that data. So I've just only drawn two different possibilities here. One is our Kafka service has the ability of directly pushing data into S3. And S3 currently supports Iceberg, Apache Iceberg. So what we can do is have Resh push the data into Kafka, Kafka push it into S3 Apache Iceberg, and we have a continuously updated Apache Iceberg table in S3, which we then can use. Or, of course, we can use the the Kafka to actually push the data somewhere else. A database here, I just put Dynamo here, but we could have whatever we want to, and we could also use some kind of processing engine, something like Apache Flink, that takes the data and then transforms it and then pushes it somewhere else. So now, what we have done is really, we've killed 3 birds with 1 stone. One is no more polling. Really, our node pushes data into our indexing, exactly what we want. We don't have to do this whole RPC business. It's just, well, not needed. Second one, no RPC calls. I put it again because it's so important. It makes it so much quicker. And then, of course, we have an optional early transformation. The Reth node itself can start transforming data. And then, of course, we can also transform data after it's been stored in our Kafka queue. So we have really these two choices where to put it. And the idea is then, of course, have the Reth node do the basic transformation, push it into Kafka, and then the application-dependent individual transformation on, say, Apache Flink or so, that then pushes into your data stores. Yeah. This is just it. So that was my last slide. I know I've taken the time. I've only put this QR code. That's again for the self-hosted graph node. I couldn't get the internal approval for the GitHub repository for the Kafka-based system in time. So it'll come out soon enough. If you want to be aware of it, just contact me on either X, Webcast, or LinkedIn, and I'll let you know. Thank you very much.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, Ethernight whisk. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange rules over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bah crack. Ooh, that lance of lightning.
My name is Meredith. I'm the co-founder and CEO at Stork Labs. We're the main development company behind Stork, a decentralized Oracle network. And I'm very excited to be here today, so thanks for having me. I will be diving into why the old way of doing business for oracles no longer works today, or I guess a little bit more strongly, is dead. And before we actually dive into the business models, though, we're going to lay some of the groundwork or foundational understanding of what an oracle is and how it's used. Oracles were created essentially to connect blockchains to external systems. The way that you can think about an external system is anything that's happening outside of the blockchain itself. That can apply to off-chain data, or it can even apply to what's happening on another blockchain. But for the purposes of this presentation, we're going to be focused on off-chain data. And to dive into really how blockchain or oracles are used on blockchains, back in 2020, 2021, the first use case with real product market fit was leveraging oracles to provide the price feeds of major cryptocurrencies for lending protocols so that they could valuate collateral positions. And just to remind ourselves of what blockchain ecosystem looked like at that time, we only had a handful of blockchains coming to market. We only anticipated a handful existing. It was incredibly expensive to launch these blockchains, so a lot of the new folks coming into the space after Ethereum mainnet and Solana were raising tons and tons of capital. And also, these lending protocols themselves were only accepting collateral positions for the major cryptocurrencies. So you could imagine, the top 10, top 15 cryptocurrencies would actually be accepted. So what that actually looked like in terms of a product for oracles to support was periodic updates on what is the price of Bitcoin or Ethereum or Sol, and putting that on a single blockchain every few hours, varying from 6, 12, even sometimes every 24 hours if there wasn't a lot of volatility in the market. And I'm not going to get too into the weeds of what the architecture looked like, but I do think it's important to just give a high-level overview of when an oracle wanted to integrate with a blockchain, it would basically have to stand up infrastructure from the ground up for each individual blockchain. So what we're looking at here is an oracle integrating with a single blockchain. And the important piece here is really looking at that third row where it says publisher. So sometimes referred to as a data publisher or an oracle node operator. But either way, this publisher would put data directly on the blockchain. So in the instance or example of a lending protocol trying to evaluate collateral, you could imagine each of these 3 publishers is publishing the price of BTC at a given time on the blockchain that they're integrating with. And then from there would be a smart contract on the chain that would aggregate that data, determine what is the actual price, oftentimes a median calculation, and then store it to that contract, which then can be queried by dApps themselves, or decentralized applications. So, okay, the things to take away from this, though, are basically if I'm an oracle and I want to integrate with 2 chains, I have to rebuild this entire stack twice. If I want to integrate with 5 chains, 5 times. So that means your costs increase linearly every time you integrate with a new chain. Also, gas at this time was pretty expensive, and the publishers were bearing the cost of each. So basically, the outcome of this is it's actually quite expensive to integrate with a new chain, and there's a lot of pressure to limit the amount of data that's getting put on chain in order to keep costs in line. Okay, so this model doesn't work anymore, and given that we're not in 2021 anymore, I'm sure everyone kind of has an inkling why, but just to lay it out, we have seen an absolute proliferation of new chains. We no longer live in a world where maybe there will be 10 legitimate blockchains. Instead, we're seeing hundreds now and anticipate thousands. So what's happening alongside this is basically it's becoming increasingly cheaper and easier to launch a new blockchain. And, we used to think of a blockchain being this general purpose chain where you could have thousands of applications building on top of it. So if you're an oracle putting data on that chain, you're basically thinking of this as a public good, right? So I'm going to put the price of or my network is going to put the price of Bitcoin on this chain, and now thousands of applications can leverage that price point. And as a result, oracles would actually charge millions of dollars to integrate with a single chain. But we're seeing this shift in market. While yes, we still have general blockchains, but we also see specialized blockchains or app chains where they're catering to a smaller number of applications or perhaps their own application, in which case spending millions of dollars for an Oracle integration makes no sense. Just to further iterate the point, there are a number of roll-ups as a service companies now. You could think Gelato, Caldera, Conduit, a number of others that make it incredibly easy and cheap to launch a blockchain or a roll-up. Basically, you can do it in a matter of minutes, sometimes even seconds. And if you're on testnet, you might not be paying a single dollar in order to do so. So if you're thinking about additional infrastructure that you need to integrate with your own chain, you're obviously going to expect that you can integrate it almost as fast and also incredibly cheap. Okay, so beyond new chains, why else is this architecture that we saw on the previous slide, why doesn't it work? Well, it wasn't designed to support low latency apps. As I mentioned, you only see updates every 6, 12, 24 hours. And as a result, the entire end-to-end flow of getting that data on chain could take several seconds, and that wasn't seen as a massive trade-off. But we now see, an increase of many dApps that are focused on real time, as well as chains themselves. In 2022, we started to see a surge of decentralized perps come to market, and that has only taken off since. There's now 100+ decentralized perps, and all of them are thinking about how can I get data as fast as possible to ensure that I'm minimizing risk on my platform. Similarly, we have a number of low latency, real-time L2s and L1s coming to market, who are all thinking, we want to be able to provide a UX to the end users here that is competitive with Web 2. And so what that means is things need to happen as low latency as possible. We're seeing block times that are sub 1 second, some even touting 50 millisecond latency or block times, and then we're with Mega ETH we're seeing some real-time blockchains in being built as well. So that means that the data that's being fed into those systems needs to be able to keep up as well, and that's incredibly hard to retrofit into something that wasn't designed for speed. And then the last one is we're seeing just new use cases come to market. So the old model was really designed for this singular use case. It was quite rigid, and it didn't support a lot of different data types. So as we try to bring new primitives to the space, new use cases for applications, that comes with that are requirements for new types of data. So enter Stork. I won't bog us down too much with all the details of what's happening in the architecture here, but I'll just talk about it at a high level from left to right, some of the innovations that we've made that we think address these problems. So first of all, overall, we've modularized the stack. And so what that means is, as a first-class citizen, we want this Oracle to be incredibly composable and support the unique needs of anyone who wants to partner with us. And we also want to be able to leverage our stack to integrate with every chain in the future. So we anticipate a world where there could be thousands or tens of thousands of chains, and it can be incredibly easy for Stork to scale to support all of them. So on the left-hand side of the screen, you can see this concept of a publisher, which we mentioned before. What we've introduced is this publisher agent. And basically, the idea behind it is there's an easy one-time setup for anyone who wants to provide data to our Oracle network. And after doing that, their data can be used on any chain. So it's a one-time setup. And it's incredibly easy to get started. We've had some publishers get up and running in production in less than an hour. The second piece here is we've introduced an off-chain aggregator. And instead of relying everything to go on-chain for verifiability, we rely on cryptographic signatures throughout the stack so that there's still traceability and you can minimize any trust assumptions. But what this means is that one aggregator can support many, many chains, or an infinite number of chains. And in order to make this actually work, the key piece is that subscribers actually have the tooling themselves. You can think of a subscriber as either a chain or a decentralized application to put data on chain themselves, and that's labeled as a chain pusher. And basically what that means is we can support an incredibly high frequency of data, of throughput, of updates, and the individual applications can determine when they actually need a data point put on chain for their unique use case. Overall, what this unlocks is we can scale infinitely without worrying about added costs, and we can cater to very unique use cases. Okay, so just to double click into some of the things I mentioned there, really the unlocks here are we have support for high performance real-time feeds. What that looks like in practice is most of our data feeds have updates every 250 milliseconds to 500 milliseconds, as well as can support conditions based off of a change in value. So for instance, a lot of the data feeds we support update if there's a 10 basis points change in price. The architecture itself is intended to be composable and non-opinionated. So that means, again, we can flex into unique use cases, which I'll highlight in just a bit. Again, easy setup for new data providers, which again makes it incredibly easy for us to support new types of assets and new use cases. We've also built out programmatic chain deploys. So basically, there is a piece of this architecture that lives on chain for verifying and storing the updates so that they can be used by any dApp. And we can have any of our smart contracts deployed programmatically via API. For example, we have an integration with Gelato, who's a roll-up as a service provider. And their clients don't even have to get directly in contact with Stork in order to include us in their app chains or roll-ups. Again, unlimited data catalog. And I think the most important piece here is this stack, because it was built to scale, can actually be made available at a reasonable cost to developers, to applications, to chains, based on what their use case is. So they don't have to worry about that millions of dollars of overhead or have to raise millions of dollars in order to bring on an Oracle partner. So, I've talked a lot about, or I've mentioned a lot about new use cases being supported. This is really what gets us incredibly excited and what I see as real differentiator for Stork. So just some examples that I'd like to highlight today. In 2022, the first example we actually brought to market with a new type of data feed supported were mark prices. So for those not familiar, a mark price is basically something that is used by most of the major centralized perpetual exchanges. And they use it to determine when to trigger a liquidation. For those who haven't actually trade perps themselves, these can be offered with 10, 20, 50, 100x leverage. So it means that they're actually very sensitive to small changes in price. And the exchange itself can be at risk if they don't trigger a liquidation quick enough because they could get stuck with the bad debt. Why do we want mark prices? That said, we want to protect the user experience. We want to make sure that we don't ever trigger a liquidation that shouldn't have happened. And basically, mark prices are used to smooth out scam wicks that can happen with very volatile assets. And so we were the first and only Oracle to bring mark prices to market for decentralized applications. These are just 4 apps that are using it now: Vertex, Apex Pro, BSX, and Rhea. But many others are as well. And we're still the only Oracle that actually supports these today. A bit more niche and exciting as well is we're partnering with Helix, which is the native DEX on Injective, the blockchain. And they've actually built entirely custom indices using Stork Stack so that they could offer new financial products to their customer base and help encourage onboarding new institutions into the space as well. A couple of those examples include they have a market for the BITL fund, which is BlackRock's fund and basically it tracks the market cap of it and allows folks to trade perps on top of that. And they also have a custom AI index, which tracks the market capitalization of both cryptocurrencies and equities that are in the AI space. We're also doing a number of other projects with them and very excited about the work that's being done there. We anticipate it will onboard a lot of new folks to the space as users. And then lastly, in terms of examples for today, we onboarded Kalshi as a data provider last year, right before the election. And for those that aren't familiar with Kalshi, they were the first CFTC-regulated prediction market in the United States. They were the first exchange or marketplace in the US that could legally offer prediction markets on the presidential election in over 100 years. And leading up to November, there was obviously a lot of excitement and anticipation about how that election was going to go. So they actually integrated with Stork because of how lightweight it was and wanting to build upon their relationship with blockchain applications. And so they provided data feeds so that applications could actually offer products on top of what is the result of the presidential election. Helix actually was a partner who leveraged those feeds, as well as D8X and a number of other exchanges too. Just some highlight stats just to kind of iterate, what adoption has looked like for this model that is quite different from the traditional Oracle model. Up in the top left-hand corner, we have total transaction value, which is essentially a measure of total volume traded on the exchanges that leverage Stork. So, massive amount. We've supported over $600 billion in volume traded over the last couple of years with our data feeds. We just rolled out the programmatic deploy for chains, as I mentioned. And in the bottom left-hand corner, we've now integrated with 50 chains, and we anticipate this number to accelerate rapidly. I think last week we integrated with 4 chains in a single day. We're supporting over 375 data feeds. We have very low latency, as I mentioned. End-to-end, the stack has under 10 milliseconds of latency, and we're supporting massive throughput or scale of data, just under 70 million updates a day. Just wanted to highlight some of the additional brands that I didn't mention earlier that are part of the ecosystem across both decentralized applications that are using our feeds, as well as the many chains that we're partnering with. And yeah, that's the presentation. We're really excited about a future where folks are able to get access to the data that they need at a reasonable rate, where oracles are no longer a blocker for innovation. And thank you for letting me walk you through all of that. If anyone is interested in partnering with us or learning more, our Twitter handle is @StorkOracle, and my email address is meredith@stork.network. Thank you.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if you chains choking Ethernight whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with do with do with do 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 do. You ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I spooked and truce from dress sheets. That's my device. Nullifier sniffing by my cloaks too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Job receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster type chump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dance scene. Bend it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifiers huffing, you're just a rat with it's fatty bits, I'm curating leaks. At the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI. Get homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency so. Notes dancing where the bottlenecks been. Professor Ways got the future on spin.
MGM, everyone. Happy Monday. It's great to be here. I'm Titus. I run go-to-market for Civic. And I'm going to be talking about making decentralized identity click. It's a topic that we've been talking about on and off for the past few years. I think we're not quite there yet. I'm going to tell you why, and I'm going to also share a few solutions on how we can make this move forward. As you know for sure, identity is a super important part of the process. I think being here at the beginning of the build cycle is super important because when you make a choice about your identity tool and your authentication tool, you want to be able to set it and forget it, make sure it works, and yeah, essentially make sure your users have a great user experience from the get-go. Well, quick intro about myself. I run go-to-market for Civic, as I said. I've authored a decentralized identity paper at IIW a few years ago. I've also authored papers on AI and identity with World Economic Forum. Co-authored 2 AI books. So I've been in the crypto space since 2017. Super excited about where this is going and how we can make identity better. So about Civic, we're a multi-chain user management platform. We started off as an identity platform, and we quickly realized that to be able to deliver the user experience that we want and be able to help Web3 builders and Web2 builders to onboard users more seamlessly, we had to go above and beyond the identity piece and build the authentication element as well. We essentially enable people to verify whether a person is a bot or not, to verify a one-person, one-chain connection, and also to verify their identity for compliance purposes. So we've issued 1 million passes to date. We're working with 600 dApps and projects on 15+ chains. We've been around for like, what, almost 11 years now, 10 years now. So 2015, we've been building for a while, and we're super excited where the space is going. So what are we talking about today? We're talking about why is decentralized identity not clicking. We're talking about what are the biggest barriers for adoption, what needs to change for us to be able to go beyond those barriers, and then I'm going to offer a few solutions, and then talk about the path to mass adoption. And last but not least, I have a QR code where there are some tools that we want to offer out to everyone building today to make your user onboarding experience more seamless. So first of all, what's going on? Why is it identity that is not clicking? Like, we agree that users should be able to control their digital identity, but the adoption is not there because of the bad UX. And by bad UX, I mean this. We went from generating Bitcoin addresses by typing or moving the mouse for entropy, and these numbers and letters on the screen, to the seed phrases, which I think for most of us, like OGs in the space, they make sense. But for somebody on the street, it's like if you go out and stop them and say, hey, do you want to create a crypto account? Like, if you store the 16 or 12 seed phrases, like, is that something that you're comfortable with? I'm pretty sure they won't understand why and what to do with them. And they'll be super worried that they're going to lose them. So that's essentially, I think, the primary UX problem in the space right now. And that's why we're all talking about account abstraction and wallet abstraction in the space. So to dive into the big problems in the space, right? First and foremost, friction in onboarding. There are usually too many steps too soon for users to do to be able to onboard to Web3 apps. So let's say you want to play your Web3 game. You've never had an account with them. You don't have a wallet. You don't have anything. You go in, you sign up. You're prompted to create a wallet. You're prompted to create a seed phrase. You're being asked about what kind of currency you want to use. You're asked about gas price, about using gas, about using certain tokens. That results in like an 80+% drop-off. If you compare this to a Web2 experience, the friction is much less there. People usually sign in with one click. The second thing that we think is a problem in the space is the lack of familiarity of the tools that are being used. So you're used to signing in with an email address. You're used to signing in with your favorite email provider or your favorite social media provider. When it comes to the crypto space, you're often greeted with, hey, use a wallet, scan this QR code, or connect a wallet that's actually a Chrome extension or browser extension. So at that point, people are like, well, I don't know what this is, and I don't trust it, so I'm not going to use it. The third problem that we see is the ecosystem fragmentation. Almost everyone out there is using a different identity layer, so the credentials are not reusable, the tools themselves differ, the verifications need to be repeated. So users end up being confused like, hey, I did this before in a different app. Why do I have to get re-verified again? And then last but not least, I think the biggest one that I highlighted in the previous section is like the security and trust concerns that people have. Because ultimately, the downside in crypto, if you lose your seed phrase, if you lose your seed words, is that you lose access to your account, your identity, your history, like everything you've created around that particular game or that particular marketplace that you've accessed. Whereas in a Web2 space, if you forget your password, then there's usually a reset mechanism. So what do we need to change to be able to create a better experience? I think first and foremost, the onboarding experience, thinking about like how can we minimize the number of clicks, how can we minimize the tools that people use, how can we create something that's familiar and soothing for the user when they come in. From an authentication tooling perspective, adding more secure sign-on options, adding more comfortable and familiar ways for people to sign in and create a wallet for them, that definitely will increase conversions. The approach to identity verification needs to change as well. Let's ask for what we need when we need it on demand. Not go on ahead and say like, hey, you need to do full KYC to play this kind of jumping chicken game. No, let's optimize to, hey, what is the attack that I'm trying to prevent? So if I'm trying to prevent a bot attack, let's just do a simple kind of liveness check. If I'm trying to prevent a Sybil attack, then let's try and do also biometrics uniqueness verification to ensure that only one user signs up per account. So simple things like that can significantly improve the experience. And then the fourth thing is credentials management, making sure we can reuse those credentials from one application to the other. And that means using standardized frameworks like the DIDs and essentially allowing people to carry their credentials from one application to the next. So how do we end up fixing this? Familiar logins and wallet abstraction is, I think, the lowest hanging fruit, and we've seen a lot of builders in the space go in that direction. Helping people sign in that way removes that friction that I was talking about. Passwordless authentication is another big one. There's been a lot of biometric tooling added. We can leverage the face auth on phones. We can leverage passkeys nowadays more and more. So using these methods to abstract that layer away from the user is helpful, and not having them remember a seed phrase. As I said, progressive identity verification, super important to ask for the right things at the right time, and then creating those interoperable credentials using decentralized networks is critical. So what does this look like in practice from a solution perspective? Now, we believe in an end-to-end user onboarding experience where people get those flexible sign-in options. There's a proof-of-person verification to empower like those trusted interactions in the ecosystem, and all that's bundled in for builders to be able to onboard users quicker and easier. So I'm going to go through both of these tools. The first one is called Civic Auth. This is where, as a builder, you can essentially choose which authentication methods you can bring on. It's super easy to use. It is generating an embedded wallet off the bat for users. And you can also onboard people with the kind of traditional wallets in the space. So you capture both the Web2 novices coming into the space and then the Web3 experts that are used to these interactions. And from a developer experience perspective, like we heard the stories in the auth space, like it's difficult to integrate a lot of these tools. So with what we've built, if you just wrap your application around with the auth provider, provide a client ID, it works off the shelf, as opposed to having to like set up all these backend interactions and do all this backend work with that requirement for other tools. I'm going to go show a quick demo here. Hopefully it works. There's nothing better than to show and tell. So give me 1 second here. So essentially, this is the onboarding for Civic Auth. You go and to be able to create a developer account, you use our auth tool, obviously. It's a simple 1-2 step. Then you essentially grab the authentication widget, very easily, kind of what you see is what you get editor. Then you grab the code that I showed earlier as well, wrap your app around the code, and then boom, you have your authentication tool up and running right away. And then if you want to add other auth methods, it's as simple as like clicking around in a few boxes, saving it, and then if you go back to the app that you've built, now the login tool allows you to onboard people in all these like new ways that you've just selected. So it's as simple as that from an auth perspective. Now, what if you want to do some level of identity verification, right? I think this is where the Civic Pass comes in. We've been building this tool for many years now. This is the one with 1 million passes issued to date. It's a robust toolkit for developers to implement user verification, access control, using things like CAPTCHA verification, using things like biometrics, using things like government ID-based authentication. Also very simple to use, has both front-end, back-end, and on-chain components. I've given this example here of an on-chain gating, basically wrapping your function around a requirement to have a specific type of token, a Civic Pass token. So if the user doesn't have it, then you won't allow them to execute that particular function. And these are the things that come into play when, for example, you want to go above, like a step beyond just the private signatures to be able to issue like a critical transaction, and you want to be able to verify, for example, is this the same person that initially signed up for the wallet and is in control of the treasury, or has this been compromised and being used by somebody else? So in the light of the recent hacks, I think this is something we want builders to think more and more about, like how can we add more privacy-preserving identity layers to these critical operations. So let me show you how this works. And mind you, this is going to be in the old paradigm, where we do ask people to connect their wallet. So essentially, you want to get a uniqueness pass in this case to be able to access a game, let's say. So you want to verify with the help of a biometrics check. This is, by the way, end-to-end encrypted. We ask for the signature to be able to encrypt the data. So once you enable the webcam verification, we go through, say hi to our colleague Mitch, and then once he's been verified, then the pass is going to be issued on chain. You can then use that in a smart contract context. By the way, the user can self-pay here. You can also pay on behalf of the user to abstract away the gas and the fees themselves. So now you see he has a uniqueness pass active, and he can now sign in or sign up to whatever app is being gated. So kind of rounding back to like the path to mass adoption, the path to mass adoption. I think like from a Web3 perspective, identity and authentication be as easy as Web2. I think we need to start more with familiar logins, add those reusable credentials. Even if like we need to expire them after a period of time, I think it's important for people to be able to reuse them after, like let's say, one verification in the same month. We shouldn't ask them to verify again unless like we have a valid reason to do that. And then just generally build that better UX that minimizes the number of clicks, minimizes the friction, the number of like other tools that people need to use to be able to onboard. So if they just like can one-click sign up with Google, sign up with Twitter or with GitHub, it's way easier for them than to create a wallet from scratch if they're not familiar with the Web3 space. And as they get more familiar, they can add those other methods to authenticate and then become more Web3 savvy in the process. So I want to leave you kind of with this thought around mass adoption. I think it won't happen because we tell people it's better. It'll happen when they don't even realize they're using it. Now, what I mean by this is, right now we use hundreds of apps every day, like dozens, hundreds of apps. For the most part, we don't care what infrastructure they're built on, if they run on AWS or Google Cloud or Microsoft Azure or a private cloud. We don't care whether they're a Canvas app or a native app on the phone. I think to be able to get to a place where crypto gets mass adoption and decentralized identity specifically gets mass adoption, we need to be able to abstract away as much as possible of the underlying infrastructure from the user so that they can have a seamless onboarding without having to have like a 2-day training on all of these tools that they need to use. So now with the practical part, we invite you to go build. Over here, there's a QR code that takes you to our docs. Get started with Civic Auth, get started with Civic Pass. Both of them are available for free right now. To try it out, please try and break them. Try and put them in your use cases. For Civic Pass, you can use them on testnet as you're building. You have super transparent and developer-friendly pricing for them. So yeah, looking forward to seeing what you guys can build with it. And yeah, let's make Web3 frictionless. I think that's the thing I want to kind of leave you with. So that's it from my side. I know we have a few more minutes, so you have any questions for me, happy to kind of hang out and answer them. But yeah, and feel free to connect with us on X, on our website, CivicKey on Twitter, and then civic.com, the website.
Architect with the buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with do with do with do 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 up do with for do with do with for do with do ho ho do. You ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, furry, hack, flurry. Mama's making news before the cold reload. Jump receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Head it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifiers huffing, you're just a rat with these firewall splinter to confetti bits. I'm curating leaves at the after party, sipping TLS tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. They rock on PI. Get homemade in 7-4 time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency so. Professor Wade's got the future on spin. Urgent notes dancing where the bottleneck's been. cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin. Bugging tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial up found. Old speak, young as each block mine down. Professor Way's got the future on spin. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin. Bugging tomorrow with yesterday's ram stains. Calling me mad, but mad's just a beta test for Buddha. Oh, he just got
Hey, how's it going, everyone? How's that volume? Can you hear me at the back? Cool. Awesome. Well, hey, my name's Ben, and I'm here today because I wanted to pose the question, Are we setting ourselves up in DeFi for a 2008-style financial crisis? And a little bit about myself and my background and why I'm interested in this question. I started my career in TradFi, and I saw how those businesses were run. That's what inspired me to join crypto. And I've been in crypto, investing and experimenting since 2016. I've been in the industry full-time since 2019, and in my first role was managing a $100 million crypto treasury, deploying into various DeFi strategies. And since then have set up my own company, raised a pre-seed, we're still in stealth, but wanted to reflect on all of those experiences to try and provide some insights and ask some hard questions about what we're building in DeFi. And so the TLDR of my presentation is I think DeFi is starting to show some cracks. Much of what I think we're building in DeFi feels like a crypto casino. And I think many of the products that are being built in DeFi right now are simply rebranded and repackaged TradFi products. And in fact, many of those products are what led to the 2008 financial crisis. Now, of course, all of this is ironic because Bitcoin explicitly was launched as a reaction to the 2008 crisis, and Satoshi referenced the crisis in the Genesis block of Bitcoin. But that said, I do think the meta is finally shifting away from the crypto casino, and we've seen that just last week, starting with meme coins. So I think now is an important opportunity to reflect on some of those things and talk about what might a better DeFi look like. So I'm looking to do that today. So why do I care about this topic? As I said, I started my career in TradFi and I saw inside some of the world's largest financial institutions, banks, wealth managers, all those sort of things. And I saw how their businesses were run, and I saw the bad incentives, and I saw how they treated their customers. So that's what originally inspired me to want to work in crypto. That same insight, that same experience is also what's leading me to be a bit skeptical about what's being built right now, though, because much of what is being built looks and feels like what I saw inside of TradFi. And so I want to make sure that we don't just repeat those same things in DeFi, in crypto. And specifically, I think a lot of what we're seeing right now looks and feels like 2008. So we're seeing funds and investors chasing ever higher yields. We're seeing innovators building overly complex products in order to address those yields. We have experts telling us the math doesn't lie, don't worry. We've got power brokers and mercenary capital that are holding the purse strings and deciding where this capital gets deployed and fueling many of these strategies. And in terms of systems, we've got assets and risks being repackaged and rehypothecated. And what I mean by that is assets being taken, repackaged and passed on to other people in order to generate higher yields. That's what we saw with collateralized debt obligations, which was the key thing that led to the 2008 crisis. We've got tides of capital that are chasing yields waiting to be deployed. We've got new assets driving up the risk-free rate. And what I mean by that, to be specific, is we look at Athena, for example. The market sort of describes it as risk-free. They're paying 9% APY. And so if I'm an asset allocator, and if I believe that Athena truly is risk-free at 9%, then I'm looking at any other opportunity. If there's an opportunity paying 5%, why would I put my capital into that when I could put it into Athena at 9%? Now, what that means is that's driving the required return for other projects higher. 9% is now kind of the minimum if you accept the premise that it's risk-free. And so you see projects and protocols and investors driving and chasing ever higher yields with mostly more leverage in order to beat those rates. And you hear people saying, this time it's different. It's crypto, it's different. Now, whenever I hear someone say this time it's different, that raises red flags for me. And specifically, what we're seeing is old risks and old products simply repackaged with new language. So we've got a basis trade stablecoin. I mean, what is that? Let's be honest. It's an off-chain hedge fund. Yes, it's been tokenized and it's put on chain, but fundamentally the strategies that are being used are just a hedge fund. Is it a stablecoin? I mean, that's debatable. You could make an argument about that. But those strategies have risk. If the funding rate turns negative, there can be a risk of asset loss. Is that stable? I would argue not. We've got restaking. What is that? That's simply risk rehypothecation, which leads to a contagion risk. As I said, that's what collateralized debt obligations were in 2008. We've got looping and yield amplification. What does that mean? They're just two giant euphemisms for a lot of leverage. We're just borrowing a lot of money and using that to power higher yields. There's nothing really innovative about that. That's been happening for thousands of years as long as finance has existed. But that's also one of the things that led to the 2008 crisis. We've got things that are quote-unquote fully backed. Are those things fully backed? In some cases, yes. In some cases, no. But even where they are fully backed, if the asset isn't liquid or that liquidity isn't available when you need it, that also can lead to contagion. We saw that with usual money. I mean, the underlying assets were there, they were good for it, but at a time of market stress in January when those assets were required, the liquidity wasn't there and a de-peg happened. And finally, decentralized. We call a lot of things decentralized. That's why we're supposed to care about this industry as builders. But, you know, I would argue most things aren't decentralized. We see frequently withdrawals get paused, bridges get paused when hacks or exploits occur. We saw that over the weekend, last week. And yeah, that proves these things aren't decentralized if a small group of people can push a button and these protocols turn off. And even more systemically, I'd say at the industry level, we like to talk about ourselves as a decentralized industry, but in reality, there's a core group of people, that's early whales, early founders, important projects, you know, large mega funds. They control the capital. They control the capital, the TVL that's deployed in these protocols. You know, it's a sort of uncomfortable truth. We don't like to say it. One of the reactions to TradFi, or the criticisms of TradFi, was these billionaires that, you know, lurk behind the scenes and pull the strings. Now, they're a different set of billionaires in crypto, but we have just replicated the same systems. Yeah, so in many ways, I'd say that the things that we're reacting to in TradFi exist in crypto and exist in DeFi as well. And so, like, why does that matter and how does that impact the industry? And I guess I want to caveat all of this by saying, yes, we're capitalists, we're operating in a capitalist system, and it's okay to want to make money and chase higher yields, but that has an impact on the industry. And specifically, you know, when we look at something that's really core to the Ethereum protocol, like staking, you'll hear people say, why would I want to, you know, stake for 3% APY when I could earn 10x that in XYZ, whatever the latest fad is? And what that means is that DeFi is riddled with bad incentives. There's like increasingly convoluted ways to generate more yield. There's kind of eye-watering headline numbers, 10%, 50%, 1,000% yields. And these projects are having to do that to compete for attention in this kind of attention economy that we have in crypto. A lot of those headline numbers are powered by unsustainable airdrops, incentives, bribing mercenary capital, bribing yield farmers to come to your protocol. But as soon as those incentives dry up, all the capital leaves. And all of this is often powered by increasing leverage as well, which is, you know, as old as finance itself, as I said, but it's just rebranded with jargon and fancy words in crypto. And all of this leads to contagion risk. And so I just wanted to make a brief aside, provide a real example that I encountered in crypto. So 2022, this is before Terra blew up, this is before Three Arrows, Celsius, FTX, all that stuff. As I said, I was managing a $100 million crypto treasury. And I had really well-respected, really smart, known people in the crypto industry coming up to me and saying, hey, Ben, you're being negligent with your company's money if you're not putting it into UST. Like, it's paying 20%. It's risk-free. Like, just go and do it. And when I would challenge people who told me that, there'd be these kind of hand-wavy explanations like, oh, it's algorithmic, and oh, you can look at it on-chain, look at the code, it's fine. There's these crypto economic incentives that make it safe. XYZ fund that is the smartest fund in the industry, they're deployed in it, and if they're doing it, you should do it too. Now, obviously all of this turned out to be untrue, but what I think it's indicative of is this kind of tendency to have hand-wavy explanations for stuff that, you know, if you peel it back, it's really quite simple. It was a Ponzi-nomic scheme. We used a lot of fancy names around it, but ultimately it was unsustainable. Now, you know, that's obvious in hindsight, and I won't claim to be smart enough to have like pinpointed the specific mechanisms or the specific risks in UST, but something about it just kind of felt off to me. The vibe felt wrong, and so, you know, I decided to stay out of it. And what I would say is that a lot of things that are getting built in DeFi right now kind of feel the same to me. They just kind of, the vibe just feels a little bit wrong. Like, can I tell you what the specific thing is? No, but I think it's an opportunity to kind of reevaluate what we're building and what's powering what we're building and ask ourselves some hard questions. And, you know, I like this meme. I always come back to it, but where does the yield come from? Like, if you can't get a straight answer to that question in 1 or 2 sentences in a succinct way, I think that should raise some alarm bells. And so, like, why now? Why did I want to give this presentation now? Well, there's a couple of reasons. The first is that the stakes have never been higher. There's more TVL, there's more assets locked up in DeFi than ever before, but also we've got real-world institutions participating in DeFi. We've got banks, we've got hedge funds, we've got governments, we've got presidents. And if some of these actors get burned, that could have lasting impact on the credibility of the industry and hurt us all. I mean, we just saw that just last week with the Libra scandal and the Argentinian president. I mean, it was a failed thing. And in doing so, that's like massively changed the meta around meme coins just, you know, in the space of a day. And, you know, if you want to call meme coins an industry, you'd say that's, you know, impacted the credibility of that industry. Now, you know, if we could see a president, name your president, deployed into DeFi and something goes wrong, you could see a similar thing, you know, reputationally rippling through DeFi. And also because of all the capital that's, you know, tied up in there and all the leverage that's been deployed, that makes the impact of a black swan event, you know, even more severe as this leverage gets unwound and things ripple through the industry. But more positively, I'd say the meta is at a turning point. The Libra controversy last week, like, you can finally see people coming and speaking out about how toxic meme coins are. I mean, I would argue it should have come sooner than that, and why did it take people so long? But, you know, there's starting to be a questioning of these crypto casino style dynamics. So I think in DeFi we have an opportunity to proactively address this and try and make things better before a crisis blows up. So that's what I wanted to do. And so to do that and to, I guess, make it more tangible what a blow-up might look like, I wanted to walk through a hypothetical. And I wanted to caveat all of this by saying I'm not, you know, suggesting that this is likely or, you know, even maybe likely, and I'm not criticising any specific protocol or restaking in general, but I just wanted to do this to make it tangible and illustrate how something could ripple through DeFi with very similar dynamics to what we saw happen in 2008. So with those caveats, let's just imagine that a popular LRT is exposed, has large exposure to an AVS, and that AVS gets slashed badly. Now, specifically why this happens, it might have been an attack, it might have been an exploit, might have been a mistake, someone was running their software wrong. Like, the specific reason doesn't really matter, and in fact, you know, by definition, a black swan event is kind of unpredictable or unknowable, but let's explore what happens next. So the expected path and the path that we all hope for is that the collateral gets slashed, but that is contained to that collateral. And because markets are liquid, the only people that lose money are the restakers. But an alternate path, which is something that I'm concerned about, is that there isn't enough liquidity. So let's say, for example, that staked ETH is the collateral asset. Lido has a finite amount of ETH on its platform for redemptions on the smart contract, and let's say that gets exhausted straight away. So now liquidity pools on DeFi are getting drawn upon. And as that's happening, there starts to be a price divergence between ETH and staked ETH. LPs start to realise that and start to withdraw their capital out of these pools. Price divergence continues, more liquidity is withdrawn, and suddenly what we thought was 500 million of liquidity is 50 million of liquidity. But even that is not enough. This sort of depegging starts to widen, staked ETH is trading at a discount, and then suddenly oracles start reporting this to DeFi protocols, lending protocols. And as I said, all this leverage is built into the system. There's all these strategies that are building on top of essentially just borrowing money and levering up. And as a result, these strategies start to be liquidated because the collateral asset is reducing in value. So there's auto liquidations. That ripples through the industry. Assets keep getting liquidated. There's downward pressure on all assets, and suddenly the entire DeFi ecosystem's been impacted. And this is obviously exactly what happened in 2008 in TradFi. We had collateralized debt obligations trading at a discount to what they were supposedly worth. Things got liquidated, liquidity dried up in the system, and suddenly that rippled through the entire global financial system. So yeah, this is our 2025 edition of the 2008 death spiral, replicated in DeFi, using the tools that we created that were supposedly a reaction to 2008. So what was bad about that setup specifically? It was a reliance on centralized protocols and sort of finite pools of liquidity, reliance on fleeting liquidity that we think was there but was not necessarily there. There's massive leverage, contagion, and cascading losses. So how would we break that death spiral, potentially? One way would be to have guaranteed liquidity provided by the L1. And luckily, what we do is, well, what we will have is that soon via the Pectra upgrade on Ethereum. Pectra-powered withdrawals provide instant liquidity and would allow validators to be drawn down trustlessly from 2048 ETH to 32 ETH. So in an event where such a liquidation was occurring, you could get that liquidity powered trustlessly by the Ethereum protocol itself. And what that means is the liquidation would be orderly, it's powered by the L1, and that contains the losses within the restaking ecosystem and doesn't cascade across DeFi more generally. And what's better about this setup is that there's no reliance on centralized intermediaries, there's no reliance on market makers or specific centralized entities sitting behind smart contracts. There's guaranteed withdrawals powered by the ETH L1, and it mitigates contagion, and as a result, there's no cascading losses. So, audible sigh of relief, that's much better. And I guess to kind of wrap this up, I think DeFi can do better, and I want DeFi to do better. I think the first thing we all need to do in this room is be more skeptical and don't believe your own bullshit. As I said, I think there's a lot of pretty vanilla TradFi products that are wrapped up in a lot of jargon and mumbo-jumbo, but really it's just leverage and it's just risk. Just because it's on-chain doesn't make it better inherently, so be more skeptical and don't believe your own bullshit. We need on-chain and protocol-powered liquidity. We need it trustless. I think projects need to keep it simple and be more transparent with what they're building, their risks, and where the yield comes from. We should be prioritizing real protocol revenue instead of Ponzi's and unsustainable airdrop incentives. And we need to be building products that people don't need to be bribed to use. They should be using it because it provides them real utility. And we just need to be realistic about risks. But all of that's hard, and I can say that as a founder that projects are competing against the crypto casino. There's a finite amount of attention out there and there's a finite amount of capital. And if you put a headline on your website that says 80% APY risk-free, there's not a lot of due diligence that goes into that, and those projects are the ones that get the attention. So the incentives that we've set up is why the industry is the way it is. And just a brief shill, what we're building is a new LST that we believe embodies these values, and the reason why we're building it is because we were concerned by what we were seeing in the industry. And we're calling it Rock Solid, a new liquid staking token. What makes Rock Solid different is that there's no leverage built into it, there's no restaking. We're offering the highest APY on the market, but we're doing that without adding additional risk and only exposing users to staking, nothing else. And importantly, as I mentioned earlier around Pectra, we're building for that. So with our LST, there'll be permissionless instant withdrawals. So you don't need to trust us as a team. You don't need to trust our smart contracts for liquidity. It'll be there in the case of market turmoil. You can access that liquidity. And we're supporting solo validators because we care about Ethereum and we care about decentralization. We're trying to take share away from these centralized entities that are frankly bad for Ethereum. So yeah, as I said, we're still in stealth. We haven't officially launched, but just wanted to give you all in this room a brief teaser. If you want to find out more, we're launching in Q2. You can follow me on Twitter, follow our company Twitter account there, and that QR code will take you to our website and all of our socials, so you can follow us and get early access. But yeah, thanks for having me today. It was great giving this talk, and my DMs are open, so feel free to DM me on Twitter or come grab me and we can continue the conversation in the room after this. All right, thanks everyone.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, Ethernight whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bah crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. To do with a do with a do with do with do. You ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scared of justice ballast on a mempool express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I scooped and truce from trash sheets. That's my device. Nullifier sniffing by my cloaks too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomping blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Let it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifier's huffing, you're just a rat with His firewall splinter to confetti bits. I'm curating leaps at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI. Get homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency sub.
insights and potential use cases of Web3 stack, particularly in DeSci in LATAM. I'm from Mexico. I'm a Coral Reef researcher. So I have been exploring DeSci and Web3 since a couple of years ago, like 5 years ago. So I just ended my master's and tried to figure out how can I onboard properly to the space. Colleagues, basically. So we're quite eager to regenerate coral reef conservation in terms of decision making, involving stakeholders for better coordination, using Web3 and DeSci. So I will present some insights regarding this topic. So it was quite interesting because last year I just presented this initiative to Web3 communities during ETHDenver. So right now we're a nonprofit. Our approach is going to be one of the DeSci DAOs in terms of coral reef conservation. Particularly right now we're working in Mesoamerica, but we have some insights for everywhere, because coral reefs are basically in subtropics and tropics. So essentially we have interesting audience. We have been supported by many well-known communities in this space, like Gitcoin, Greenpill, Optimism, Givet, and many of these guys are here somewhere. So right now, this is interesting because this is an interesting topic. This is a particular use case. We have been exploring the sociological system of coral reefs since decades as researchers. And these are basically the global threats that these ecosystems have. They're quite impacted by cyclones, by sea temperature, by ocean acidification. And the particular thing that we have here is coral reef. A coral reef is basically the unit of this ecosystem. So essentially, these ecosystems provide goods and services to many people, involved in this system. So, in terms of shoreline protection, tourism and recreation, fisheries, and basically is the lives and property businesses. Usually these ecosystems thrive with people, everywhere. So essentially we're creating and prototyping this product. It's called Region Reef, and we have our headquarters is based in Mexico, in Telchac. We have an extension there with a research center, and we have like 6 hectares there to develop this prototype, and basically, explore and decentralize science in terms of coral reef restoration and conservation in many hotspots that we have just identified in the Caribbean, in Latin America. So Cozumel is one of them. Laurinburg Cay is another one. We have been done some exploration there. Cayman Crown in Guatemala, Rotan in Honduras. And basically this is our general approach, to achieve that. We need to create community, essentially. We need to implement decentralized science in a proper way with a particular use case with stakeholders, and we are quite eager to involve a little by little, this regenerative finance approach. And eventually, we believe that we need to regenerate science at a certain point. So essentially, this is our basic conservation framework, and I will explain a little bit more regarding this. We have just identified in the framework of conservation, this article was published by Brown in 2022, and in every process of conservation, we could implement tools that we know in the Web3 space. So we have been exploring this in terms of how can we leverage citizen science with stakeholders with particular use cases in the region. So I will present some exploration that we have been done. This is our main product, essentially. We want to create our leverage biotech, marine biotech, we research with some restoration with a sociological component and essentially create a DeSci hub worldwide, because many people are quite interested to get involved, and we need to create a new coordination mechanism using these Web3 stuff, So basically, we have been prototyping since years ago, igloo-shaped modular wet labs, and we're planning to scale this using the Web3 stack that we know, in terms of on-chain metrics for potentially create new products, essentially new markets, essentially, biodiversity credits and carbon credits. That's our ultimate goal in the long run. So essentially, we have 2 prototypes, one of coral restoration and one of fish restoration, and we were eager to accelerate research, like I said before, but in terms of natural product extraction, because we have seen that in the DeSci space, many individuals are quite focusing a little bit in longevity and regeneration stuff. So we just identified that many biomolecules that we could potentially explore to create essentially to close the loop in many conservation projects, in terms of coral reefs, because we have extractive practices since decades ago, in many conservation frameworks. And essentially, our headquarters, like I said before, is in Telchac. We have a huge basement there, and we're quite planning to scale it, on the long run. So these are some prototypes that we have in terms of coral restoration. It composed by many components. Microfragmentation area, a robotic area, a waste treatment area, essentially a biobanking area. And this is basically the theory that we want to apply with on-chain analytics and Web3. As you may see, corals is a holobiont. This holobiont, essentially, we could explore what are the proper, we could explore everything, with this organism. 3D printing bionic coral, natural product characterization, extraction, and the ultimate goal for this will be close this loop in terms of conservation or restoration efforts, to close and create a really retroactive, funding this kind of tools. So essentially, the scheme that you could see in my left is basically the REFI framework that we have been just explored a little bit. And for example, we have a demand of climate action projects in Latin America, and we're quite eager to support many stakeholders that we know to onboard them properly to the space. And for example, we need to create, that's why we're here, to find and incentivize developers to explore a little bit more this regenerative approach of things, in terms of blockchain. And we believe that we need a really good accounting service in terms of off-chain data, in terms of standardization, origination, verification, data management, the things that we have been done a couple of decades ago, with all these sensors, SIGs and all this kind of stuff, IoT sensors and all that, big data. So essentially, the governance layer comes in the middle, and this is how the blockchain protocols work. You could essentially leverage this accounting to create a new market. We're quite eager, and we're quite exploring this. So these are two main areas or studies that we are quite trying to onboard a little bit into Web3 component. This article was published in Frontiers Marine Science, and we really want to create an on-chain counterpart of this particular project. This is a proof of concept, and actually we're quite supporting this initiative. And for potentially, growth coral reef fish species, and we could potentially create a market regarding this, a sustainable market. So essentially, we're quite eager to implement in every stage of this method, some Web3 components, and we're quite going on this. This is the other part regarding fish. Like I said, this is basically the model, the framework that we just created in terms of post-larvae rearing and the nursery fish area. So this is the framework that we're quite developing. We are quite developing the protocol level. Probably will be a EVM compatible technology. The governance level, we're quite working on that too. Incentive level, organization level, operational level, and the application level, the ultimate goal. Regarding our highlights that we have been done, we have been crowdfunding like 33K USD. It's nothing compared to many well-known Web3 protocols, I know. But yeah, we have been supporting with that 30 conservation actions in Latin America. We have around 60 members in our community in Discord. We have like 22 months of existence, and we have been quite present in 15 Web3 and science forums, traditional science forums. And these are part of our partners. Many of our members are being quite involved in initiatives like Coral Connect, Wave of Change. This is counterpart. This is a part of Iberostar Hotel Group. Grupo Curates is a counterpart that we have in as a private entity. Healthy Reefs is basically charted in the US, Coral Reef Alliance too. And yeah, we are quite eager to create a socio-ecological component, with our stakeholders that we have been known since years. So this is why this was quite surprised me this year, because we are highlighted in this PhD Gens. It's time for a DeSci update, by Messari. So many of these initiatives usually have a lot of presence in the space, and we're quite eager to be selected here because, look, we're here. And we have been, like I said, we have been funding some research, traditional research, and we're quite pivoting and iterating some Web3 components in each conservation traditional framework that we have. And we have only 2 initiatives of Latin America. We have DeSci Latam here and Mesoreef DAO only. So I believe that the potential use case, in the global south is huge, in terms of regenerative finance and DeSci particularly. So this is an evaluation that we just created with some colleagues. The total addressable market in this initiative is around, the blue economy itself is around 3 trillion, if you want to see numbers of the potential use case. So coral reef ecosystem contribute 2.7 trillion annually, for a report of WWF. So the AI environmental monitoring market is projected to reach this amount of money by 2027. So essentially, our initiative is quite eager to create new opportunities to create a new wave of independent researchers in the global south, if you want to see that way. And we need that, I don't know if you have seen how's the situation in traditional science here in your country. So imagine that. In Mexico, for example, in Latin America is worse than here. So yeah, this is the serviceable available market that we have, 1.9 billion, and it's growing in terms of compound annual growth rate, like 13.2%, annually. So the refi impact investing sector, all the deep end structures and all that will be around 1 trillion by 2030. So, and basically it's quite aligned with the sustainable financial goals by the UN and other entities, the World Economic Forum and all that. So essentially, these are the serviceable obtainable market that we just evaluated. Many stakeholders have just contacted from many parts of the world, Mesoamerican Reef is one of the top, reef tracks that we have in the world. The Coral Triangle has another potential, and the Great Barrier Reef. And essentially, potentially, this will be the first ecosystems that will be quite extinct, functionally speaking. So we need to take care of them and try to build stuff, for this, It would be quite messy to see the extinction of these ecosystems by the end of the century. So yeah, and basically the key stakeholders that we were quite focusing, marine research institutions, conservation organizations, public goods and Web3 communities in the DeSci space, and refi investors. So yeah, in terms of the unique positioning, we're quite eager to integrate AI, refi, and token-gated impact, with governance tokens or whatever. We're quite open to discuss that. That's why we're here, essentially. So we're planning as an NGO to be the bridge in conservation, unifying these concepts about technology, DeSci and refi. We have been quite a good traction, and you will see. These are part of our members. As you see, many of us are really good at the conservation itself of coral reefs. Coral genomics, invertebrate ecology, sociological artists. We have some sociological artists involved. Climate change top researchers, and yeah, coral reef ecology professors. So, and we have Antonio, that is Google and Web3 Dev, and me, that I'm quite enthusiastic with the technology itself. So these are some prototypes that we have been funding. We have just created 4 different field trips regarding the traditional frameworks that we have, and we're quite implementing, with the scholarships with the people that actually need, that are quite volunteers in our lab, and in trainings, in token-gated trainings with the people. And we have these synergies with other institutions. This is part of the curates program that we just support. And as researchers, we have really good impact, in some traditional research in academia, as you may see. Last year, we just did this article, in terms of reef vulnerability and bleaching in the Mesoamerican Reef. We just we're more into the theoretical aspect of things. This is a really good framework and research article regarding unifying coral reef stress through space and time. So essentially, region reefs, we're planning to scale in hotspot areas in Mesoamerica, with this approach. And we have a really good expertise on this. So this is a protocol, a treatment protocol that it was a publication regarding this. We're quite eager to put some experiments on chain, So this is quite interesting because other DeSci initiatives have been done that. that, and we're quite eager to explore a little bit. And for example, last year, personally, I just won a scholarship of DevCon, and my mission was, okay, we need to create to people to get involved in this, but not necessarily to be quite involved in my initiative, in our initiative of Methodology DAO, you know? Because, for example, I just wanted to explore a little bit how was the investor side of things in that area, you know? And many investors are quite aware that, you know, Southeastern Asia contains like 11 countries that depend directly of coral reef ecosystem. Singapore is an island, for example. And I just wanted to explore a little bit how's the perception regarding that, you know? And it was a really good exploration. And in terms we just present the initiatives in the DeSci Hub in DevCon. We just participate in the Visible Garden as mentors, in the Shanghai Wu, in the Artiverse too, in the Lopungs. So, and many other, you know, events. For example, this one of DeSci Bangkok by the Foresight Institute and some colleagues. And this is quite interesting because, as I said before, we have just involved a little bit in the traditional academia, you know. So we just participate as advisors, as coordinators in the Reef Futures Congress. This Reef Futures Congress is a well-known coral restoration consortium. You know, it's a congress basically. They do it every 2 years, and essentially we just participate with a workshop in DeSci. You know, we're quite focusing a little bit in researchers and in stakeholders that depends of these ecosystems. So it was really good. We just presented like 11 different papers surrounded this quite topic that we're quite researching on, and essentially, it was a good experience. And actually, we're quite endorsed by this initiative by the UN. We're part of the Decade of Restoration inside the Cozumel Coral Conservatory. And, you know, we're working with stakeholders to automatize this living structure called SOE that is based in Cozumel, you know, to implement little by little the DeSci stack, you know, this kind of conservation efforts. So this is our report, the recap that we have in 2024. Last year was quite interesting because we just explore and identify many issues that have our stakeholders, and potentially we're quite eager to do some collaborations, even with developers, even with business people. You know, we're quite open to leverage this kind of efforts, you know, to scale properly. So actually, we just participate on a series of talks by the Mexican Society of Coral Reef Ecosystems, and this chapter particularly is part of International Coral Reef Society. So essentially, we're quite making presence, you know, in the traditional field, and we believe that we need to create a hybrid model, you know, in terms of research, and how can we implement or use the DeSci stack to leverage this thing. And actually, I have not seen any POAP in this ETHDenver. So we have a POAP here for our initiative. If you're quite, or if you identify and you love these coral reef ecosystems, we just have this special POAP for you during this event. So I think that's all for me. So contact us and reach us if you want to build something good, you know, a particular use case for this. Thank you.
Tears, call me well connected, I call it. Drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. Watch me be rock on PI. Homemade in 7 for time. cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Waze got the future on spin. Urging notes dancing where the bottlenecks been. Professor Waze got the future on spin. Bugging tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building? Prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs xylophone. Old to speak, young as each block mine down. Professor Waze got the future on spin. Urging notes dancing where the bottlenecks been. Professor Waze got the future on spin. Bugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a beta test for Buddha. Oh, he just got you. 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 We're biddies, not just dreamers. On-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff-eyed corns are still a-growing. While the world is breaking down in a new way. Some VC said this tech won't last. And the herd bubble, watch it crash. But we don't need your central banks. Cause region biddlers stack in stacks. For we pity led this city on sports and chains. We pity led this city with region brains. We pity led this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some TradFi bro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pity let the city on sports and chains. We pity let the city with region brains. We pity let the city on sports and chains. No rug pulls, just pure on chain.
One of the founders of Nuffle Labs. So Nuffle Labs is a stake from anywhere solution, which essentially allows you to stake tokens from any L1 or L2 to Eigenlayer. But what I'm going to talk about today is something that Ethereum community has been working around for a while, and I'll deep dive into the question of, is chain abstraction solving anything? So we talked about this last year. I was actually giving a presentation on this one. There were roughly like 40 different L2s at that time. But if we go now and try to count them, I think it's like 100 plus. We're also seeing a lot of like new EVM L1s come into the game, like Barachain and Story just launched last week. And we also have another EVM coming in, which is Monad. But interestingly, like we're also seeing a lot of AltVMs, which is, I've seen the Eclipse guys today, but we're also seeing a lot of like Solana VMs being sort of taken to Ethereum as an execution environment. And we even have things like Movement, which is a sidechain to Ethereum as a Move VM, and things like Fuel, which is coming from the Ethereum community, but started to build their own sort of execution environment just for scaling rollups. So what I call this is kind of, we're getting this like blockchain salad, and that's kind of like a word salad that you see. The problem with this is that you have multiple wallets, multiple assets, and it's really hard for users to manage all these chains. So this is something that we've been like looking very closely. So community's first response, it's been chain abstraction. It's been one of the most dominant discussions we've been seeing since 2024. One thing that I've observed over the last year is that, well, users are no longer tied to a single chain. We also saw a lot of sort of growing user overlaps between Ethereum and L2s, Ethereum and Solana. But when I go to folks and ask what chain abstraction is, the definitions quite vary. Like some people talk about unified balances, some people talk about bridging, some people talk about intents. So I want to deep dive and see what people are sort of, when you ask that question, what's chain abstraction, how people respond. So one of them is, I took some tweets to just explain, because most of the conversations take place in Twitter about chain abstraction. One guy said, well, chain abstraction is all about unified experiences to simplify multi-chain interactions. So it's basically merging all your access passes at Disneyland into one big pass. I like that definition, so I just wanted to put there. The other one is hitting the complexity from users. So if you're moving from one chain to another, obviously, you don't want to see all the complex interactions. Some chain abstraction tools are allowing you to do this, where you can just come in, you can use one front end, and you can swap. The other thing is, which is Ilya, whom I used to work with at Near, it's this concept of unified account balance, which I'll explore later too, which is quite exciting, where you have USDC in a bunch of different chains. You don't want to just like aggregate all of them to one chain and then do a transaction. Instead, let's imagine a product that can do a swap from USDC to Solana, but the USDC can come from any L2, any L1, and you do that swap. But overall, like if you look at these different approaches, you can play with Grok, get like 7, 8 different definitions as well. But one of the most important things is obviously just, it allows you to simplify multi-chain interactions, which is something that obviously Ethereum community is working on. So there's been a lot of sort of attempts to basically make sense of it all, because there's a lot of companies, there's a lot of products that are working on chain abstraction. One of the things that, I was actually one of the attendees in a couple of workshops as well, is this cake sort of framework. You can divide this into sort of 4 different components. Let's say layers, because we like layers in crypto. So application layer, which is essentially the sort of the interaction layer, the front ends that people interact, or the mobile apps that people interact. You see this sort of different variations of different user sort of experiences. You obviously have the permission layer, which is accounts, sort of key managements, policies, and intents, which all of us have been sort of discussing for a while now. You have the solver layer that takes the intent and does something with it. So it's, if in an order book, it fulfills the request. And finally, you have the settlement layer, which is final transactions and the bridging that needs to happen, basically clearing and almost like quote-unquote clearing in traditional finance. Obviously, you would think that this would solve fragmentation, but if you look at, obviously, this market map, you see that there's a lot of companies or protocols that are trying to do similar things, and they all have their own flavors, right? So they, for example, if you look at the order flow, there's 22 different ways to do different order flow through different protocols. And just like what we did with a lot of, if you look at the tech history, we had a problem, we created a bunch of different standardizations, and then now you have different standardizations that are competing. And if you look at traditional sort of tech history, that's been usually a problem. And what I think is that it's actually making this problem a bit worse. And you see this all the way through in crypto, right? You have layer ones that were having problems with scaling. To do that, there were newer layer ones that's been launched. Obviously, rollups on Ethereum have been emerged, which ended up being a lot of bridges. And those bridges led to fragmentation of liquidity. And with these liquidity, obviously, you saw a lot of bridge aggregators come in and trying to solve the problem. And I think that chain abstraction has a very sort of promising future. but we should not repeat that same pattern. This is an interesting, I brought up, there's been a couple of discussions around, does chain abstraction solve really anything, right? So we started with the fragmentation, are we solving really anything? I think it's a common criticism, but I want to kind of point out to some products that are quite interesting that is solving the UI UX problem. I think it's the first sort of the problem that chain abstraction is trying to solve, but then I'll sort of portray a picture how the future of chain abstraction should look like. So first, this Infinex experience that I really like. Essentially, if you're a multi-chain user and you want to basically swap one token to another, let's say from Solana to Arbitrum, you can actually do this in Infinex in a couple of seconds, which is quite interesting. So we didn't have this experience before. Obviously, you have stuff like Portal and others, but quite love the experience. So definitely go and check it out. I think it's something interesting. The other one is Universal X. I know I see Tabasco here, which is one of the chain abstraction KOLs, which is quite interesting too. Well, you can do cross-chain swaps, but what if, I said the experience before, you have USDC in all different chains. I actually did a swap today. That $95 has been, I think I swapped it to Arbitrum this morning. Though your USDC could be on different chains, and you just come in, click, and actually buy OP. I bought OP apparently. And then I bought OP in a couple of matter of seconds. It settles quite nicely, and for like small transactions, it's amazing. And you have Near Intent, which is very personal to me because I worked at Near. One of the problems that we had as an ecosystem was that when Near launched in 2020, there was the rainbow bridge between Near and Ethereum. That took almost like 8 hours to sync, which was a bit of a problem if you want to go to Ethereum. Now you have Intent solving that problem to, in a matter of seconds, you can swap Near to Solana tokens, Ethereum tokens. So I would say like cross-chain chain abstraction solved some of the UX problems that we had on cross-chain swaps. But I think we can, there's certain things that we overlook, which is EVM, which this community has created. EVM is one of the things that people have been discussing on Twitter over yesterday, whether if you're launching an EVM L2 or an EVM L1, are you actually doing something with Ethereum? I would say EVM has been great to outsource some of the work that Ethereum wasn't able to do on Ethereum L1, do some of the experiences outside, like, for example, Monad is a great experiment, and take them back to Ethereum to scale the L1, scale the L2. But overall, we underlooked the premise of EVM. I think there's certain things like working at an alt VM, you get technical familiarity. If you have new devs that are coming to the ecosystem, there's a lot of technical work that's being done with the Ethereum community. New devs or some devs that are coming from Ethereum to another L1, you can actually leverage a lot of smart contracts, which is interesting. There's obviously economic advantages, right? So the shared liquidity that we're seeing with a lot of the Aglair has been putting work. There's a lot of Ethereum community has been pushing towards this economic advantage of it, and EVM has played an amazing role to be able to interrupt different layers, and obviously reduce fragmentation. I'll mention some of the ERCs as well, but overall, historically, ERC20, ERC721, all these standardized you can take these and then deploy to a new chain, and it works. Usually, it works to the new chain as well, which is quite exciting, and I think something we should look forward as Ethereum community. One thing that actually attracted my attention last week, Ethereum Foundation published this work, which is Open Intents Framework. So it is some sort of solving this problem of we're seeing too many of the chain abstraction standardization. What if somebody comes in and agrees with all the parties like Starknet, Polygon, Arbitrum to have one Open Intents framework? I think it's pretty promising to sort of unify Ethereum L1 and L2 landscape. This is ERC 7683. So quite excited, right? We start with a sort of one standardized way to do intents, which is something that the community has been working on for a while. So where does it take us next? I think cross-chain swaps are pretty interesting, but DeFi has been mainly focusing on sort of fighting for the same ETH. So every L2 came in, they basically did some incentives, got some ETH, and then when the incentives run out, the Ethereum just left that L2. But what I want to focus on as a builder is top 20 assets have been sort of almost remain underutilized, right? If you look at, and I give this analogy, Ethereum is like you're up in the 1500s where you have the advanced technology, but resources need to come, there's resource constraints on like gold and others. So I think Ethereum can go other sort of blockchains, get some of these assets and make them usable in like lending or other markets. So I believe like the future of DeFi lies in bring those assets to the Ethereum L1 and L2 and make them usable. And I think chain abstraction is the way to do it, right? So you had cross-chain swaps, but what if you have cross-chain lending and borrowing, all these sort of quote-unquote structured products that you can create in DeFi that could sort of take some of these assets that historically have been sort of subject to chain racism, but now you can pretty much get that liquidity in and use it in Morpho or other permissionless markets. So I draw this picture. It's a very basic way to look at top 20 assets. The pricing might have changed. I know the market caps have been moving slightly over the last sort of month or so, but these are all assets that are pretty much almost like no smart contract utility. Didn't have, for example, Bitcoin, XRP has some, but Doge has been, it's almost a fork of Bitcoin. And when you look at them, like DeFi utilization rate is drastically low compared to Ethereum. Like Ethereum stands something around 16%. And when I say DeFi utilization rate, it's a very basic metric. You can go even further and make it more complex, but I just took literally like TVL divided by market cap, and Ethereum sits at 16%. But once you look at chains like Bitcoin, now it's 1%. I know Bitcoin DeFi has been taking off. We see Lombard BTC on Ethereum L1 being used in Morpho and Aave markets. But assets like XRP, Doge, these are very open. Like that's something that is interesting to take these into more deeper markets like Ethereum and give them usage so that basically users come to Ethereum L1, come to Ethereum L2 from different other chains and make them basically use the asset here rather than bootstrapping their own liquidity, bootstrapping their own DeFi, which Ethereum has been working on for ages. So the question, is chain abstraction solving anything? I think we've had like sort of a solid foundation with some of the tools that we built, intents, bridges, message passing technologies. They weren't there last cycle. Like Layer 0 was just about to come to the market. Wormhole was actually got hacked and got worked on getting the security improved. I think we're coming to a perspective where we can actually go more than cross-chain swaps, and this is mainly that we are working on in Nuffle, is to push cross-chain lending, is to push all these structured products I can create. And one thing I just wanted to highlight, like EVM is an amazing tool that we built over time. Although AltVMs are coming, people should sort of experiment with new AltVMs. EVM has done a great job of standardizing most of the work that we're doing, and I think we can do that with Open Intent Framework too. And essentially, we should work towards expand Ethereum DeFi's access and sort of create seamless cross-chain DeFi experiences that chain abstraction should be working on. And ideally, we talk about interoperability, but it's really about like getting sort of these assets used almost financial inclusivity. It's a bit of a term, but essentially taking these assets and being used on Ethereum to make Ethereum more liquid in a way is, I think, what chain abstraction should push for. Yeah, thank you for listening. So this is Nuffle. You can follow us on X. I'm also pretty active. Try to be more active these days. Been working a lot in the background, so my account is there too. And if you scan the QR code, you can find all the information about Nuffle as well. So 5 minutes, we can take some questions about chain abstraction or anything that you guys can jump in. I'll try to hear you, but it's. Yeah, it's great. So V4 and hooks and all the work that I'll actually show you. Let me see. This was part of Open Intent Framework as well, so you can see the unit chain. It's been great. So like the intent experience have been created by Uniswap. It's been sort of working with the Ethereum Foundation and push that sort of standardization. I think is good for everyone. So intents will become, as far as I know, will become part of the unit chain, and also will probably part of all the Ethereum layer 2 ecosystem pretty much. If that's all, yeah. Thank you for listening.
cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin, urging those dancing where the bottlenecks been. Professor Way's got the future on spin, bugging tomorrow with yesterday's ram stains. Chaos is not compeller, order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial-up found. Old as speak, young as each block mine down. Professor Way's got the future on spin, urging those dancing where the bottlenecks been. Professor Way's got the future on spin, bugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, Pete Jones, drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7 Shaboom, dose, efficiency pulse. The lad runs lagging in his latency so. Professor Way's got the future on spinball. Urgent.
All right, hello everyone. My name is Samantha Oyang. I'm a 20-year-old nomad on a gap year from UPenn M&T right now, and I've been working in crypto since I was 16. And so starting from last October, where I spent 2 months in Thailand at multiple different pop-up cities, I've been working on something called Survivor, which is a platform that empowers sexual assault survivors to report their abusers by matching victims of the same perpetrator together so that they know that they're not alone and can find a path forward together. So a little bit about my personal story. So I've been traveling around for crypto conferences since I was 17, and the first time that I was ever sexually harassed was when I was in Austin for South by Southwest that year. And that essentially made me hate the city ever since. But I ended up returning to Austin 2 years later for Consensus. So this was around May last year, and I started working on this idea in honor of my younger self. And at Megazoo in Edge City in Thailand, I became re-inspired to build this project out because I actually had to report my Airbnb host for sexual assault in Cambodia right before coming to Chiang Mai. And I myself was so scared to report, and the numbers reflect this too. 75% of sexual assault cases go unreported. Victims are afraid to speak up because of fear of retaliation, defamation lawsuits, reputation loss, and all of these other reasons listed here that create something called first mover disadvantage. And so Survivor works to eliminate that first mover disadvantage by allowing survivors to create a timestamped record of their assault and be matched with victims of the same perpetrator. Victims can submit a report where they can fill out as many identifiers as they know about the perpetrator, including things like name, email, socials, physical features, location, etc., document what happened and upload evidence, and then verify their identity or KYC using ZK email or World ID. And this is essentially to prevent false reports or defamation. And then I also previously successfully implemented GPT-4o when it first came out to be able to describe an uploaded image, and that would basically be able to help process image data submitted in reports. And then second, building on top of Cursive's technology, the system leverages multi-party computation, or MPC, specifically private set intersection to identify overlapping information in the report submitted without revealing anything else about their identity. And then from here, a network of victim nodes develop from overlapping data in the edges. And so this forms a knowledge graph structure. And so clusters will eventually start to form around specific perpetrators identified as more pieces of the puzzle are revealed from different victim stories to form a more comprehensive story. And the survivor nodes may gain access to the network of other survivors in the cluster. And then lastly, once victims become part of a cluster, they can check their perpetrators to see the number of reports filed against them and match with other victims of the same offender. The platform also notifies victims when these matches occur and offers them the option to connect in an anonymous private chat to find support in solidarity with each other. And so this is just like a little bit of a demo of the implementing GPT-4o, and essentially it's able to identify the things in an image and then translate that to text. Here's just a little bit of a demo of the front end. So essentially, you fill out a form to essentially report a perpetrator, and then all of the fields are optional to fill out. And you essentially want to fill out as many things that you know about the person. And then at the end, you choose a verification method. So here I'm using World ID to essentially verify that I am a human submitting this report. And then after that is done, you can go back to the original, it brings you back to the original page and you click Submit Report, and that's processed on chain. I also use Arbitrum Stylus to help me write my smart contract, and this was pretty much used to store data about the reports in structs and write related functions, as well as help identify and count the overlapping reports. And then after DevCon, so at Zoo Thailand, I started working more on the graph architecture that I mentioned earlier. And so this was a little bit of a whiteboarding session that I did a while back while I was still teasing out the details. And so first I worked on training a graph neural network using PyTorch for the matching algorithm. And so the different fields like eye color, license plate, or phone number are encoded or embedded to become node features. And then the GNN, or graph neural network, learns these embeddings so that it can identify or classify whether these nodes represent the same perpetrator or not. And then now with this GNN and then using Ezekiel, very funny, I actually bumped into the CEO of Ezekiel this morning when I went to Torchy's Tacos. It allows you to prove the trustworthiness of the model, and that it's acting in good faith without having to reveal any of the sensitive data submitted by the victims. And so now I'm just going to go into a quick walkthrough with some sample data. So this is the information that essentially is collected through the form. And as you can see here, even though these two reports aren't exactly the same with the same strings, you can tell that they're probably talking about the same perpetrator, given that it's talking about a John Doe and a John D. And they're both, one is Hispanic and one is Mexican, and it's happening in a similar area. And so there it brings a higher confidence rate. And then you can probably tell that they're likely the same person. It puts it into the same cluster. And then here's also a similar example, except this is for Jane Smith. You can see that she's white and one is Caucasian, and then they're both located in NYC or New York. And then lastly, here's a little bit of an outlier. So report 4 has no commonalities compared to any of the previous ones. And so you end up with like a graph structure that looks sort of like this, where the ones that are similar are grouped together, and the ones that are different are grouped in a different one. And so here's just me running the program. And so essentially it creates vectors of different node feature encodings. And at the bottom, it generates edges if they are similar enough. And so these are bidirectional edges. And so based on the graph before, you would see that 0 and 1 are linked, and then 1 and 0 are also linked, and then 2, 3, and 3, 2 are linked. And if you line up the array on the edge indexes on the side, you can see that it is the case. And you also see that 4 is nowhere to be found because it does have no edges attached to it. Here's just a little bit of like the tech stack that I used to build this. And yeah, here's some of the traction that I've gotten so far. So since starting this project in October, it's gotten a lot of traction that I'm really grateful for. It's gotten a lot of widespread support from people who are really eager to bring it back to their own respective communities. Like I've gotten people who are interested from like the modeling communities, jiu-jitsu, even like the club scene in Berlin, and so many more. And I started working on this around the time of the news about DWF Labs. And then from there, I shared my own personal story about what happened in Cambodia and also my why for working on the project. And then that tweet sort of went semi-viral as the crypto community really came together in support of sexual assault awareness and safety at networking events. And my story was seen by a lot of different notable figures that I've been following for a long time, like Laura Shin, like the really famous podcast host, and also the executive producer of the Vitalik movie. And then at Edge City, I ended up winning 4 prizes at the hackathon as well, including first place in the arbitration track and also the Community Choice Prize, which was essentially where they just set every finalist project on stage, and whichever got the loudest cheer ended up winning. And it just felt really heartwarming to have an entire crowd just cheering at the top of their lungs for me. And then after that, the judge from Arbitrum actually did an interview with me, and that was posted on Twitter. It got reposted and quote tweeted a lot, felt a lot of support from there. And after that, people just began sending me money to my EVM address, and so that was really crazy. And so on the bottom right, I think you can actually see, I like told my dad about, oh, like someone gave me money for this, and he was like, oh yeah. He was basically just like joking about how like I shouldn't disappoint my investors. And yeah, after Thailand, I'm just following up with a lot of the ecosystems that we're really interested in supporting, and just looking into different grants. And I'm also looking for someone like a technical co-founder or anyone who would want to help on this project. And so yeah, thank you so much for your time. It's been an absolute pleasure to speak at ETHDenver this year. And let's come together to hold perpetrators accountable. Thank you.
Wow, wow. Inflation stuck to the ceiling. Why? Gas fees are confetti. Watch me be rock on PI. Get homemade in 7/4 time. Shaboom, dose, efficiency pulse. The lad runs lagging in his latency sub. Professor Waze got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Waze got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins, they cack. Self-sustaining hubs flicker in the blackouts out. Professor Waze got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Waze got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Chaos is not compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI
All right. Good afternoon, everyone. Thank you all for being here today. And in case you don't know me, I'm Hanzhi. I'm one of the co-founders of NewBit. And I'm also a PhD student at UCSB, where I do research in blockchain security and ZK technology. So today, I'm going to introduce our recent work on push-button verification for BitVM implications. So let's get started. First of all, everybody is celebrating the bull market, where Bitcoin is hitting all-time highs again. And however, despite introduced in the same paper by Satoshi, Bitcoin as the currency and the Bitcoin network are like two opposite extremes. So on one side, Bitcoin dominates over 60% of the market share, and with over 20 billion daily volume. And on the other hand, Bitcoin as the network can only handle 4 transactions per second. And how many can Visa handle? It's 24,000 per second. So that's a huge gap. And given the previous numbers, it's not very hard to understand while there are like hundreds of Bitcoin ecosystem projects early last year, such as Layer 2, Oracles, DeFi, and none of them went very far due to this brutal limit of Bitcoin. And with, let's say, ordinals and inscriptions, we immediately see the consequence of the limitation via network congestions and rising fees. So there are also many Bitcoin native projects, including a bunch of Layer 2s, DeFis. They claim to solve this problem. And however, if you analyze their data flow, none of them goes far beyond their own centralized servers. It's because getting their transactions settled on the Bitcoin network is not only expensive, but technically highly non-trivial. So what can we do? Luckily, we got BitVM, originally proposed by Robin Linus 2 years ago. It was born to address this limitation. So the high-level idea of BitVM is very easy to understand. So since the computation power of Bitcoin is both expensive and limited, so let's move the heavy lifting computations off-chain and only defer the on-chain validation process with an on-chain verifier deployed on Bitcoin. So you only need to trust science and like Bitcoin network instead of any third parties or centralized providers. It's much like an optimist way to verify computations on Bitcoin. And with BitVM, the future looks awesome, right? But why we haven't seen anything yet? Well, because making BitVM from a prototype in the paper to a product is highly non-trivial. It's extremely challenging. So why? It's because Bitcoin script is not Turing complete. Just like any programs, you first have to implement BitVM. Let's say we pick a Glock 16 verifier for ZK snark in some high-level programming languages, such as Rust. It is pretty simple. It's easy, as you can only need to write a few hundred lines of code due to there are already very sophisticated libraries, such as Arcwork. And since this program needs to be processed by a compiler to an IR, and all the way down to its low-level Bitcoin script. And now I hope you can understand, notice the issue. So why? We all know that Bitcoin script is Turing incomplete. And you may ask, what do you mean exactly? So, well, if you think of the expressiveness of EVM bytecode as A dots, who can express her rich emotions, such as happy, sad, angry, the expressiveness of Bitcoin script is like a 1-year-old baby who can only has 2 states, cry and not cry. So that means translate such a small program, a ZK verifier into Bitcoin could be extremely large. For Glock 16 verifier, it will take 1 gigabyte of data. And manually construct such a complex and large program may highly possibly introduce security vulnerabilities. So what we can do? So to solve this problem, to ensure the correctness of such program, we need a proper formal verification tool for Bitcoin script. So our key idea is simple. So we want to automatically verify Bitcoin script, BitVM implementations, So it's very low level, that relies on some complex stack operations. So instead of manually checking this code, our approach translates this low-level Bitcoin script into a higher-level, clear representation. And then, like you can think of it as like converting this dense technical instruction manual into some plain language instructions that are much easier to understand and verify for computer. So the first stage of the whole process is to convert Bitcoin script into what we call a domain-specific language, or DSL. So this DSL abstracts away the messy details of stack operations by replacing them with register-like operations. So imagine you have like a complicated card trick that involves reordering cards in a very precise way. So our conversion process takes that complex procedure and rewrites it as simple steps like add, copy, move, much like clear instructions. So this results in a cleaner, simplified version of the original Bitcoin script that we can analyze much more easily. And after we have this high-level DSL, the next phase is to automatically verify this code. So this is where we check that the converted code meets its intended behavior. So we use techniques such as loop invariant and symbolic execution. So the core contribution here is the loop invariant. So the loop invariants are conditions that must hold true before and after each iteration of a loop. So by summarizing the effect of repeated operations with a loop invariant, we capture the essential behavior of the code without having to like inspect every single step. So this can make the whole process more scalable. And imagine you put a giant Bitcoin script with millions lines of code, since there's no control flow, and you need to unroll all the loops. And this would be a disaster for the symbolic execution. So with loop invariant, to summarize the behavior, the solving time can be much less than the vanilla way. So together with these methods, loop invariant, symbolic execution, and the high-level DSL, we simplify the verification conditions significantly, allow our tool to automatically confirm that the specific Bitcoin script is correct. So essentially, we are taking a very complex set of instructions and reduce it to clear logical statements that is much easier for the solvers to verify. And now let's look at some concrete examples. The first example is the big-int multiplication. So big-int multiplication is a crypto operation that's used in many blockchain protocols. It is used to handle very large numbers. Numbers are so big that they can be processed with standard types. So it is used in BVM, in CK proof, in ECDSA. Basically, every single crypto protocol needs this operation. And in the original Bitcoin script, to implement this big-int multiplication is extremely hard. As seen on the left-hand side, the script must manually handle each limb of the large numbers. Essentially, it's the trunks of the large big integer, and it uses a series of stack manipulations like duplication, rotation, shifts, and it also needs to track all these operations by hand, which makes it super hard to verify. And using our tool, we first convert this low-level script into our high-level DSL. So in this representation, the sequence of stack operations is abstracted into clear, higher-level instructions on the right-hand side. So for example, instead of repeatedly moving pieces around, our DSL expresses the entire multiplication using a loop that updates two key variables. So one represents the current result, and the other represents the multiplicand, and which doubled at each step. And a loop invariant is then established to capture the relationship between these variables after each iteration. So this invariant states in simple term, the result so far equals to the original multiplicand multiplied by the process bits of the multiplier. So with this concise summary, so our verification tool can quickly check that the entire multiplication is performed correctly without getting lost in the low-level Bitcoin script details. And our tool is blasting fast. So we can talk about our experimental results. So we evaluate our verification tool on 78 different benchmarks from BVM, and the results is kind of promising. So our tool successfully verified 83% of all the cases, and the average verification time per benchmark was just 12 seconds. And this tool, we compare this tool with the vanilla solutions, which simply convert the Bitcoin script into verification conditions without any looping environments and inference. It shows faster verification time and can solve much better benchmarks. And importantly, our tool also identified a previously unknown vulnerability. So for example, here on the left-hand side, there is a buggy implementation of is positive, which will count 0 as a positive number, which is wrong. So and on the right-hand side, it is the fixed version. And this bug is discovered using our tool. To summarize, our work push button verification for Bitcoin script basically simplifies and automates the verification of Bitcoin scripts, and which shows practical impact on improving the security of real-world applications such as BVM. So if you are interested in our work, feel free to scan the QR code above, and have a nice day. Thanks for listening.
With the buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with do do You ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I spooked and truce from dress sheets. That's my device. Nullifier sniffing on my clothes too crisp. Mainnet gossips tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Job receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Blood eyes everywhere, match 3 bird phones. Haunteries whisper king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Head it up to the entropy. Mace cracked vaults like who's got the keys? Nullifier's huffing, you're just a rat with His firewall splinter to confetti bits. I'm curating leaps at the after party, sipping TLS tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling. Why? Gas fees are confetti. They rock on P.I. Get homemade in 7 for Shaboom, dose, efficiency pulse. The lag runs lagging in his latency so. Professor Waze got the future on spin, urging notes dancing where the bottlenecks been. Professor Waze got the future on spin, plugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the boot fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Waze got the future on spin, urging notes dancing where the bottlenecks been. Professor Waze got the future on spin, plugging tomorrow with yesterday's RAM stains. Chaos is not compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's if your chain's choking Ethernight whiz. Found her at a bullet hook sucking down APIs, armor clinking with tomorrow. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial-up-found. Age? Old to speak, young as each block mine down. Professor weighs out the future on spinball. Urging notes, dancing where the bottlenecks been. Professor weighs out the future on spinball. Plugging tomorrow with yesterday's ram stains. Throwing me mad, running mad's just a beta test. A bullet over all the jobs. Just dreamers, on-chain truth, no middle schemers. For eyes every day. Cows are voting, vibes are flowing. Buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And the herd bubble, watch it crash. But we don't need your central banks. Cause regen biddlers stack in stacks. For we pity led this city on sports and chains. We pity led this city with regen brains. We pity led this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. CK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games.
Check, check.
Thank you so much. What's that?
Today with you guys. My name is Oscar Serna. I'm a lead developer at Thraco Labs, which is part of the Forte ecosystem of partners. And today, we're going to be talking about higher precision with larger numbers in the EVM. And I'm going to start this talk by spelling the T. $2.2 billion were stolen from DeFi protocols last year alone. And a good chunk of these hacks were due to precision issues in the math. For example, the Onyx protocol in September of last year got hacked through a rounding issue of a very small number that was magnified by a flash loan, and that's how the hacker got to steal $3.8 million. You can find many, many examples like this, like the Raft protocol that even went through many audits with top-of-the-line auditors like 12 Bits and Hats Finance, and they still got hacked. So going through audits is not a guarantee that your math is safe. That is just to say that the precision in the EVM is paramount. But don't worry, we have been working really hard to make the EVM a safer place for math-dependent applications, and that's what we're going to be talking today. All right, so who are we? I mentioned earlier that I'm part of Thraco Labs. And you can think of Thraco as a company focused on helping people to build successful blockchain economies. We're working closely with Forte in this regard. And as such, we have been developing AMMs, among other products. And that's why we have been so involved with math. However, what we have found is that the mathematical tools at our disposal are not enough to guarantee good precision, and that's why we have been developing our own tools, which is what we want to share with you guys today. All right, and as I mentioned, we are part of the Forte ecosystem of partners, and what we do is we serve developers across the entire Web3 sphere, from those working with real-world assets and stable coins to DeFi platforms and gaming studios, ranging from independent developers to industry giants like Zynga and Jam City. All right, now let's get straight to it. This is just one example of the math that we do. As you guys can see, it's a complex equation. This is just C of n. It's just one example. However, a lot of things can go wrong with the precision in this equation. There is a lot of things involved. This is pretty much a hacker's dream come true. All right? I'm not going to get into details here because I don't have much time. But just know that there is a lot of things that can go wrong here. All right, so this is just a refresher. Most of you guys already know this, but what are the main challenges when dealing with math in the EVM? As you guys know, the EVM is an integer math beast, so there is no concept of fractional numbers, and Solidity pretty much is the same way, right? There is no concept of floating points or fixed point math in Solidity. We do have a fixed point type, but it is not implemented yet. So we pretty much don't have it yet, right? And that is pretty much where all of these rounding issues come from. The fact that we don't have a way to store or express fractional numbers in a safe way. That's what hackers take advantage of to steal your money. And another constraint of the EVM is that it is a 256-bit architecture, which is, and the math in the EVM is modular, which is really cool, and it allows you to do a bunch of stuff. But if your numbers start to grow larger than 256 bits, then you have a problem. However, as you guys can imagine, already some projects have been working on this, and this is just an example of the state-of-the-art of the EVM as it is today. We have a bunch of fixed point math libraries. Most of them work with 18 decimals. Some of them work with 27 decimals. Solidity is just one of them. And the fixed point math is the most popular way of doing math with fractional numbers in the EVM. We also have floating point libraries like the ABDK, which implements a very popular standard in computers for floating point numbers by the IEEE. However, floating point numbers are not very popular in the sphere because most people think they are just imprecise or not safe for the blockchain. And we also have libraries like the UN512, which pretty much allows you to do math with numbers larger than 256 bits, but smaller than 512 bits. So pretty much what I'm trying to say here is that we have tried to overcome these limitations of the blockchain by developing these kind of libraries. However, what we have found is that if you want to do crazy math like this, then these tools are probably not enough, or it's going to be very hard for you to have good precision with them. So that is exactly why we have been building our own solutions, and we want to give them to you today, guys. We have built two solutions. We have built the UN1024 and the Float 128. So I'm just going to start with the UN1024, and it is noteworthy, worth noting that this is 100% an integer math solution. And the concept of this library is really simple. Just like the UN512 library, this library allows you to do math with numbers as large as 1024 bits. We actually built on top of the UN512 library because it uses very, very cool math number theory concepts like Chinese remainder, Helsing's lemma, Montgomery reduction, which we extended. We also implemented our own algorithms that we developed. And what is very cool about this library is that it's very powerful when you couple it with fixed point math. So why is it so powerful? Because this way you can store as many decimals as you want, and your precision can be very, very, very high, even if you're doing math like this. So all of a sudden, with the UN 1024, you can do a very, very straightforward implementation of pretty much any equation that you can imagine. All right, so let's go straight to how to use this library. This library, we decided to build 3 types. As you guys can see, these types are pretty much like the sizes of the numbers that we can manage. So you have the UN 512, the UN 768, and the UN 1024. And we also are showing how to use them. In this case, we have the subtraction case. You can use the struct version, or you can use the unpacked version. The reason that we have both versions is because with the structs, this is the more usable way of using the library. However, it is also the more gas expensive way. So we're not limiting you guys to do like one or the other. You can just do what is convenient for you to do. All right, and real quick, let's go to the pros and cons of this UN 1024 library. So as I mentioned earlier, the pros are that it is perfect to couple with fixed point math libraries. It also has exact precision in all mathematical operations. And it allows you to do math with numbers that are 4 times larger than what Solidity allows you to do out of the box. However, there are some downsides. As you guys can imagine already, one of the downsides is the gas consumption. The truth is that the larger the number, the more gas it costs to do operations with it, as is expected. We have made it very efficient, but it is still something to consider, right? Another con that we have is with this library is that different types make it a little bit cumbersome to use in some cases, and I'm going to explain a little bit better this. So because you need some type in the inputs, and you might return other types in the output, you're going to find yourself writing equations in a way that is going to be like, if you implement an equation that is like A multiplied by B plus C over D, most likely you're going to end up doing something like A multiplied by B, save the result, add plus C, save the result, divide by D. And the reason is a different type. So if you multiply a UN 512 by another UN 512, your result will be a UN 1024, and that's pretty much the reason that you have to do things like that. All right, so those were like some of the reasons why we also decided to explore other options. And we decided to explore the floating point solution, and we created actually a library to manage floating points. So a lot of people, like I said earlier, are scared of the floating points in the blockchain. However, what we have found is that they have very, very interesting properties that might be perfect for most applications out there. So I'm going to go ahead and explain. But before that, just a refresher of some concepts of floating point numbers. We have a floating point number pretty much is composed of 2 pieces. One is the mantissa, and the other one is the multiplier. And here you have an example of one single number that is represented in 2 different ways in the floating point format. The mantissa in the first case is a -124, and the other one is -12400. And pretty much the multiplier tells you where the radix point is going to be located in the number. The multiplier is also composed of 2 different pieces. One is the base, and the other one is the exponent. In this case, both are base 10, and the exponents are -6 in the first case, -8 in the other one. Okay? So now that we all remember what the different pieces of a floating point number is, I'm going to explain real quick how our library was built. And our library is called Float 128, and it is base 10. The mantissa has 38 digits, and this was thought to store as much information to have as much precision, at the same time being as much gas efficient as possible. Our types are signed, so you can do signed math out of the box. And our exponent range goes from -16,000 to positive 16,000, so you can do, you have a huge range of numbers right here. What we decided to do was to implement two different types, and I'm going to show this with the next slide. If you guys look at the image at the top left of the slide, you're going to see two different types. One is packed float, which is UN256 under the hood. And you have also the float, which is a struct composed of two integer pieces. One is the mantissa, and the other one is the exponent. The reason we decided to do this is pretty simple. It's because one is optimized for storage. The packed float is optimized for storage since storing information in the blockchain and reading from it is one of the most expensive things to do. We decided to create the packed float. However, with this type, you have to encode and decode for every operation, and that's why we also have the float, which is the one that you don't have to encode and decode. However, if you want to store information in the blockchain, it is going to be more expensive. All right, and here we're exemplifying the addition case and also how to pretty much convert from a fixed point to a floating point. It is very simple. You simply wrap your number as an int. You use it to packed float, and the -18 pretty much is saying that this is an 18 decimal number, which is the most popular fixed point math that you can find out there. And the way you add is very simple. You just do the number dot add parentheses the other number. All right, now, what are the pros and cons of this library? So real quick, it is very easy to use. If you compare this with the UN1024, it is actually easier. And the reason is that there is no size or concept of size with these floating point numbers, because the exponent pretty much adjusts itself, and so they all fit in the same type. Versus in the UN1024, you have all of these types, right? Another pro about the floating point number, and this is floating point numbers in general, is that they can store the information in a very efficient way, again, because of the exponent. And a very cool property about the floating point numbers is that they are very precise for small numbers. And I'm going to explain this a little bit better. If you guys remember when I started this talk, I mentioned the Onyx protocol was hacked because a very small number had a rounding issue, which was then magnified. And that's how the hack happened. Well, it turns out that happened because most likely they were doing fixed point math. And with fixed point, you have the disadvantage that when you have a very small number, you're pretty much already using most of your decimals to just store zeros, right? And so that pretty much any truncation of the decimals is going to be magnified when you multiply. With the floating point numbers, this doesn't happen because what you do is you always store all of your number with 38 digits in our case. So you always have 38 decimals, and you just adjust the exponents. So most likely, if the Onyx protocol were working with floating point numbers, the hack would have probably been avoidable, right? However, the flip side is also true, though. With very large numbers, fixed point math is superior to floating point numbers because you cannot store all the information you need in a floating point number. What you do is you just truncate. Like in our case, you truncate after the 38th digit. Another very interesting property is that it's very gas efficient with large numbers, and it is also in comparison with the UN1024. I mentioned with the UN1024 library that the larger the size, the more gas it needs to do operations. This is not the case with the floating point numbers because, again, there is no concept of size. You simply are dealing with the mantissa and the exponent pretty much says how big or how small the number is. So they all cost the same. Now, the flip side is also true, right? If you're dealing with normal numbers, normal size numbers, or small numbers, you can say that the floating point library is actually more expensive because with very small numbers or normal numbers, you can just use the math that Solidity gives you, which is very cheap. All right? So we have been talking already about some pros and some cons already. Now let's explore the downsides of this library. One of the downsides is that being a floating point number, it is not exact as integer math. I put here fixed point math because under the hood, fixed point math is just integer math. So that is true. However, what we have found is that the imprecision is pretty much insignificant. Also, numbers with more than 38 significant digits will lose precision. That is a case that is mostly related to our implementation of the floating point numbers. And the reason is, I mentioned earlier, if you have more than 38 digits, you pretty much truncate it and you lose that extra information. However, again, that information is considered insignificant for precision. And the last point is something that I already explained. It is not very efficient in gas terms for small numbers because you can do operation with small numbers with solidity very, very cheap. All right, and I'm just going to mention this. It is an edge case. I'm not going to go into details here, but just know that if you're dealing with math, subtraction is very, very dangerous for your precision. The reason is that if you have a very huge number, and if they're very, very similar, all of the most significant digits are going to cancel each other, and it's going to leave you with the least significant digits, which are prone to have the least precision. So, actually, fixed point math is superior to floating point math in this case. However, there are tricks that you can do in your equations to make it safe also with floating point numbers. All right, and as promised, we are making public our libraries. We want people to start using them. We're actively working on them as we speak. And you guys are welcome to submit PRs to the libraries. We are still maintaining them. And what's coming with these libraries, right? So with the UN 1024, we still want to do more optimization in our algorithms. And in the Float 128, we're still adding some functionality. And we're also thinking about increasing the amount of digits that the Mantissa can hold and going from 38 to 71 digits to make it very, very, very precise. Like, this is going to be like very, very precise. However, it comes with the cost of more gas consumption. So we're thinking of how to do it very precise, but at the same time, very gas efficient. All right, and that's it from me, guys. I just want to remind you that the CTO of the company, if you guys are interested on why we're using so much crazy math, right? Well, we're building AMMs, as I explained earlier, and tomorrow the CTO of the company, Neil, is going to be giving a talk about updating AMM to bootstrap liquidity in a stable manner at Captain Ethereum stage at 5 p.m. Thank you very much.
My name is Lorenzo Barbantini. I am the founder of Colossus. Colossus is a European company. We actually started off as a validator, and then I say that we became custodian by accident, as we were faced with the initial challenge of delegating assets from regulated custody. So basically what we do, our vision is that we believe that the future of Web3 rests on the shoulders of institutional capital. And that's why our mission is to foster that innovation and to help institutions coming into this space. How do we do that? So first of all, one step back and let me discuss who's in the journey with me. So we have a core team with 4 founders. Gianni is the IT expert, more than 25 years in IT. Myself, I have been in telco and startup spaces for over 10 years. Andrea comes from the institutional finance background. Florian, who's our 4th founder, is a lawyer. And then we have Andrea Torrente and Raj. One is our CTO and the other one is product manager. So with quite diverse backgrounds. So we see and we believe that there is a big gap in the market, which is the whole reason for my talk. So the gap in the market is that it is very complicated to interact with regulated and licensed custody platforms. So very few tokens support it. I'll just do some examples. I don't know, here how many of you are actually utilizing custody solutions, but let's start with Fireblocks, one of the market leaders. Fireblocks only supports presently 3 assets, and when they support these assets, of course I'm saying about custody, they support thousands of assets for custody, but only few for staking. So, and even when they support them, they have deals with validators, and so the choice that an institution has is very limited. Okay, so that's the first point. The second one is that the support for new tokens is very slow, because these companies have other focuses. And when you're talking about things like Bitcoin staking, which has been the flavor of the month during the month of December, it's not even on their timeline. And so if you want to interact, you have to develop the transactions yourselves and with what that means. So the market is quite fragmented, but I'll get into that in a second. So the market, asset holders want to hold multiple assets. They are today utilizing multiple custody providers, and they want to use multiple validators. So of course, in this, what's happening is that you have both the custodians and the validators that are developing their staking dashboards. So custodians, of course, have their staking dashboards, but even there, support for assets is very slow. Maintenance of these dashboards is very cumbersome. Every time that there is a soft fork or something happens on the chain, you have to update the transactions, otherwise nothing works anymore. Same thing goes for the validators. And now if you're an asset holder, in this case, you end up having to interact with many different platforms. So you would have the platform of your custodian that maybe doesn't speak to the validator you want to speak with. And so you end up having multiple platforms you need to access, and there is no central place where you're able to manage your assets. So coming back to custodians, they're limited to what their custody solution providers enables them to do. So if you're using Fireblocks and you want to, do Bitcoin staking on Babylon, it's not supported today. You can stake, but the transaction unstake and unbond is not yet supported. And so that kind of creates, I would say, an issue. And of course, even custodians, today, if you're, again, using Fireblocks, there's only 2 validators. One is Kiln and one is Figment. Validators are facing basically the same issues. They have customers. These customers are large customers that are holding their assets in a licensed custody. And those assets are complicated to get out. So, institutional users, many of them, let's start from the end. So asset managers I already described. These are companies that are holding large quantities of assets. They need to be able to generate yield when the assets are idle. And so here, what we're allowing them to do is to access a very simple platform and to be able to generate yield directly from custody without moving assets. I think that the events of the recent days keep on reminding the institutional customers that counterparty risk is a very significant topic to be careful about. The other one, VCs. Now, VCs, these are companies that make investments into new projects. So now, of course, once they make an investment, this project needs to be custodied inside their custody solution. And if that project is in the infancy stage, there's probably a lot of decisions to make in terms of governance. And no custody solution today supports governance. Governance is a very close relative to staking. So one of the things that we're doing is also enable governance. Exchanges have hundreds of tokens supported and launched on their centralized or decentralized platforms. And they want to be able to offer those customers, their customers, staking, and they want to be able to offer it natively without having to go around their own security procedures, therefore doing everything from within their custody solution. Foundation, even more, because as a foundation, you're launching a new project, and this new project is probably not going to be supported by any of the custody solutions because it's just launched. So one of the things that the platform does, it allows you to store these assets inside a custody solution through the mechanism of derivation of wallets, and then allows you to also stake that same token if, of course, staking is available. Custodians and validators have exactly the same problem, just seen on different ends. So the custodian wants to send assets to the validator, but doesn't have the technology to do it, and so therefore doesn't know how to craft a transaction directly from within the custody solution. And the validator has exactly the opposite problem, wants to get those assets, but is not able to pull those assets because those two platforms don't speak. Meet the institutional hub. So basically, we've created a marketplace, a two-sided marketplace, that on one side connects to the custodians, the ones that I just described, so anybody that is holding assets in a custody solution. And on the other side, allows those customers to interact with any validator of their choice. So it's a two-sided B2B marketplace. Think of it like a retail staking hub, but instead of connecting your MetaMask, your wallet, or anything of that kind, you're connecting the API of your custody solution. So you're using Fireblocks, you're using Ledger Enterprise, you're using DFNS. You can do all of that directly from this platform. Again, if you're an asset manager and you're using 3 different custody solutions and you're using multiple validators, this platform allows you to access the assets in different custody solutions and to stake them to any validator of choice. So when you stake from custody, here you have a very simple toggle menu. You go from Fireblocks, Ledger Enterprise, DFNS, then we're working also on other solutions. We also have online HSM, so cloud-based HSMs, offline signing with offline HSMs. So it's basically bring your own custody to the platform, and we'll interact with that custody solution. And this, everything is pure raw signing. No smart contracts, no widgets, no iframes, no dApps. Nothing that can be fiddled with, and everything totally transparent, because transparency in this market is the name of the game. And so, okay, the tokens that we support, many tokens, but here just what I wanted to highlight is that you have Fireblocks that supports 3 assets, Ledger Enterprise supports 6, now it was 5 before. We support all of the other assets. So of course, as customers require more assets, we're, now last month was the beta chain month, and so we're now supporting beta chain, and the next one's going to be Ton. So now we're driven by customer demand. So our unique selling points are very simple. We make it usable, we make it safe, we make it compliant, and we allow every single part of the transaction to be verified. So nothing needs to be done on trust. How do we do that? So we've created something in the flow. So I'm going to show you a brief video in a sec of how the platform works. I actually have it live, but as I was told that everything needed to be offline, I have a video. But I'm happy to show anybody live that wants to see a full transaction from Fireblocks, Ledger, or DFNS of any token that we support. So this is a transaction lens. So when you create a transaction, before you sign the transaction inside your custody solution, you're able to verify the hash. Hash is a one-way function, so from the clear transaction you can get to the hash, from the hash you can get to the transaction. So the only way of having mathematical proof that what you're signing is what you want to sign is to verify that you're generating the same hash. So the transaction lens shows you the clear transaction on top, the readable format of the transaction, and then the hash, which is the one which needs to be the same one that you're going to be signing inside your custody solution. We've even got one step further. We have created a decoder based on open source libraries that we give away for free to all our customers, and then invite them to insert their libraries, because verify, don't trust, but you shouldn't just trust us. You need to trust yourself and trust the code. And so here again, you do the same thing. You take the clear transaction that you have copied from the transaction lens, you insert it here, you get the readable format, and you get the hash. Once you have the hashes which are the same, now when you sign it, you have mathematical proof that what you're signing is what you want to be signing. Okay, so I'm just going to show it to you, might as well. So this is how the platform looks. So we're going to be using Fireblocks. This is the UI of the platform. And now we will go to the back end. Now, this is what I was showing you before. This is how you interact with different custody solutions. You interact one custody solution at the time, and the API is a read-only API. There's no signing, there's no moving. It only initiates a transaction so that you're always 100% sure that if anything would happen, this API can't do anything that you don't want it to do. Okay, so now here we're checking Fireblocks. It's the one that we're using at the time. So now we're just going to do a delegation of Atom. Okay, so now when we click on delegate, the API is checking what we have inside. Now we've just inserted the secret of the API, which we've created on Fireblocks. Of course, the same thing, it's slightly different, but depending on the custody solution that you're using. And so now that makes sure that we're signing and we can send the transaction to our custody solution. Now what we have here, on this side, institutional customers want to do things in a compliant way. So maybe they have a compliance policy or transaction authorization policy that requires them to sign the transaction in more than one user. And so in this case, we have an MPC on top that basically shards the key, and therefore more than one user crafts the same transaction. Only if the transaction is the same are you able to send the transaction on. So now, no threshold needed. We send the signature request. And as you saw before, this is the transaction lens that pops up immediately. This is something that the operations teams of large custodians very much like, because that means that everything is blended into the flow of the transaction. Everything is done in front of them. Of course, then they still have to take a separate source, which is the Colossus decoder, or something that they want to do to make sure that they're signing the correct hash. So now you copy the transaction, you go to the Colossus decoder, you choose the token that you want to use, and you get exactly the same, of course, you get exactly the same result. Now here you see we're inside Fireblocks. This is the custody solution. And so now we have a transaction pending authorization. So this is a transaction which has been initiated by the hub. So the marketplace has initiated a transaction. The only way of knowing what it is checking the hash. And the hash is what we check through the transaction lens. Basically, what I'm going to do is I'm going to show you the same transaction done on all of the other platforms. So this is how you sign on Fireblocks. You have a Fireblocks app. And this is how you sign. You come back to the institutional hub, because now you have to check that the transaction is broadcast. So you see the latest transaction up there. OK, now you go to the Explorer link, and you check the transaction has really been done. So everything, always checking, never trusting. Now we do exactly the same thing on Ledger Enterprise. I didn't have to show you how the initial piece works, but it's exactly the same. You insert the transaction, readable format, clear hash. And we check it inside Ledger. Ledger has, this is the UI. Ledger requires a signing through an API. So here you'll see the transaction is signed now. So there was a pending transaction, and now the transaction there has been signed by the API of Ledger Enterprise. And again, we come back to the hub. We broadcast the transaction. We verify the transaction went how it should go. Here we have the Explorer to confirm everything. And now we will do the last custody solution, which is DFNS, just a different solution. Exactly, works exactly the same. So the experience is consistent even when you're changing custody solutions. So imagine an institutional customer that is using multiple custody solutions, like they do, that can access the platform and has it all in one place, perfectly neatly done in a very simple way. So here we have the decoder again. We check that everything is kosher, that we're signing the hash that we want to be signing. And this is the signature inside. DFNS and Ledger Enterprise have a wallet architecture. Fireblocks has a vault architecture. This is a wallet architecture. So in this case, I'm signing a raw signing. This is where the hash would be down there. And so before approving it, I have checked on the transaction lens, and I have checked on the decoder that the transaction is what I want to be signing. We approve the transaction. So first we're checking that the hash is correct, approving the transaction. And there you go. And that is it. So super easy. I hope I managed to give you some insights about this market, and I'd be more than happy to show you the platform live. Please check me out if you have any questions. My Telegram is down there. So looking forward. If there's any questions, I'd be happy to answer. Thank you.
With the buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess. Scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI. Get homemade in 7/4 time. Shaboom, dose, efficiency pulse. The lad runs lagging in his latency sub. Professor Waze out the future on spinball. Urging notes dancing where the bottlenecks been. Professor Waze out the future on spinball. Plugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Waze out the future on spinball. Urging notes dancing where the bottleneck's been. Professor Waze out the future on spinball. Plugging tomorrow with yesterday's RAM stains. Chaos is not compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored out, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial up found. Age? Old to speak, young as each block mine down. Professor Waze out the future on spinball. Urging notes dancing where the bottleneck's been. Professor Waze out the future on spinball. Plugging tomorrow with yesterday's RAM stains. Running mad's just a beta test for Boodle. Oh, P-Jobs, just dreamers, on-chain truth, no middle schemers, forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen fiddlers stack in stacks. For we pity let this city on sports and chains. We pity let this city with regen brains. We pity let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fight bro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking Ethernight whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. To do with for do with for do with do with do with do 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 do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing on my coats too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, not just 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Head it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifier's huffing, you're just a rat with These firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI. Get homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency so. Professor Way's got the future on spin, boy. Urgent notes dancing where the bottlenecks been. Professor Way's got the future on spin, boy. Bugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. bumblebee. Optimize the orphans, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin, urging notes dancing where the bottlenecks been. Professor Way's got the future on spin, bugging tomorrow with yesterday's ram stains. Chaos is not compeller, order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial up from age. Old to speak, young as each block mine down. Professor Way's got the future on spin, urging notes dancing where the bottlenecks been. Professor Way's got the future on spin, bugging tomorrow with yesterday's ram stains. Running mad's just a beta test for Buddha. Oh, he just got to do. 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 Just dreamers, on-chain truth, no middle schemers, forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen biddlers stack in stacks. For we bid let this city on sports and chains. We bid let this city with regen brains. We bid let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some TradFi bro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we bid let the city on sports and chains. We bid let the city with regen brains. We bid let the city on sports and chains. No rug pulls, just pure on chain. If you fade it, just stay seated. The Etherverse will leave you heated. We don't need your legacy, 'cause regen memes are brew upgrade. We bid let the city on sports and chains. We bid let the city with regen brains. We bid let the city on sports and chains. Rolling up and slapping chains. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, Ethernight whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bah crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. To do with a do with a do with do with do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a mempool express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall, eyes spooked and truce from trash sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, that's 3 bird phones. Haunteries whisper, king chomping blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Heading up to the entropy. Mace cracked vaults like, who's got the keys? Nullifiers huffing, you're just a rat with these firewall splinter to confetti bits. I'm curating leaks at the after party, sipping tearless tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI. Get homemade in 7 for a time. Shaboom, dose, efficiency pulse. The lad runs lagging in his latency sub. Professor Way's got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Way's got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Bees flutter like drunk bumblebees. Optimize the bookends. They cackle and shout. Self-sustaining hugs flicker in the blackouts out. Professor Waze got the future on spin. Urging notes dancing where the bottlenecks been. Professor Waze got the future on spin. Plugging tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I've got to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial-up-found. Age? Old to speak, young as each block mine down. Professor Waze got the future on spin. Urging notes dancing where the bottleneck's been. Professor Waze got the future on spin. Plugging tomorrow with yesterday's ram stains. Test for Boodle. Oh, he just got you. 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 Just dreamers, on-chain truth, no middle schemers, forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash. But we don't need your central banks. Regen biddlers stacking stacks. For we pity let this city on sports and chains. We pity let this city with regen brains. We pity let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go we pity let the city on sports and chains. We pity let the city with regen brains. We pity let the city on sports and chains. No rug pulls, just pure on chain.
Hi everyone, my name is Jessie. Can you hear me well? Yeah. Thank you so much for being here today. I can see people that I know in the stage. Hi Saskia and Tommy. Today I'm going to speak about how the girlies can leverage SocialFi to make a brand and also to monetize their influence on chain. To be honest, like I didn't know that by just like posting fries meme, it would kind of like change my career. And before I start, if you want, you can scan the QR code here and follow me on X. There's a link tree, and you can then follow me on Lens, Farcaster, YouTube, and all the other platforms. So I want to start by telling you my story because I think it's important for you to understand where I come from. So I started off my career as a visual artist in France. In 2015, I graduated with a master's in fine arts. And after that, I worked as a professional artist for like 3 years. I was invited to artist residencies in Shanghai, Singapore. I also did a lot of like group shows in galleries and museums, but after 3 years, I noticed that I was not even getting paid. And I was super fed up because there were two things. Like I couldn't identify with, you know, this image of the struggling artists. And the second thing is that I did a master's. So there's two things. You can do art as a hobby, but if it's your profession, if you wrote a thesis and if you have a master's in hand, you should be able to earn a proper living. So I just decided to create my own startup. I went to business school in 2018 at ESCP Business School in Paris. And I had two choices. The teachers told me that I could either write a traditional thesis or I could write a more professional thesis. And because I wanted to create a startup, I decided to go with the professional thesis. And so I developed a project called Art from Future, which at the time was like a marketplace that would connect young artists with their audience. And basically, at the time, there wasn't so many marketplaces. Like, it was super new. Most of the traditional art world was, like, offline. And if you were trying to build a marketplace, it was seen as something, like, super bad. But I didn't care, and I just decided to kind of, like, create a plan. I made a business plan and an action plan for that. And later, in 2020, when I moved to Finland, I decided to do an accelerator program called curates, which led me to create an MVP. So all by myself, I created a marketplace, gathered some artists, and after, we collaborated with influencers. And influencers were here to create content so that content could reach millennial art collectors. Actually, what I wanted to do was to democratize art and to remove intermediaries. But 2020, I don't know, I don't remember, but everything went fucked up because there was COVID. And I started hanging out on Clubhouse. And on Clubhouse, I discovered NFTs. And I was like, oh my God, like that's what I've been looking for so long. You know, you can just, as an artist, you can just create art, put it on the internet, on the blockchain, and then sell it to whoever loves your art and wants to support you. So I started off first as a collector, then as an artist. And I noticed that people were really vibing with my art. So I was creating art around the motto, fries before guys, in it for the fries. And it was more like a joke because I don't know if you guys remember, but in 21, there was a lot of guys who were posting stuff on Twitter like, I'm in it for the culture, but they were really in it for the money. And I mean, it's okay. Everyone wants to make money. I want to make money. You guys want to make money. But I feel like, why be hypocrites, you know? So I decided to go with something a bit more like girly, and I think that the fries before guys thing was like really fun. And I noticed that crypto artists like OGs like Stella Bell were really vibing with my art. She started buying my PFPs on the Tezos blockchain, and she was really like pushing me to continue. And this is when I, you know, understood that I was doing something right. So basically, like, I also found like supporters, but also investors in my project because I was chilling fries on Twitter. Then in May 2022, I saw someone post about Lens, and then I was like, what is that? Basically, you could just like mint your social graph. And I noticed that Lens was, very linked to Stani from Aave, and Stani is from Finland, and everything related to Finland, I find it super cool. So then I was like, okay, I'm just gonna, I'm gonna check it out. So I minted my social graph in May 2022. But later, in September, October 22, I started being like really active on Lens. And this is where I understood that there's a real community and people trying to, change things and build like communities. So when I started off on Lens, I was so lost because I was like, oh, damn, like I have to create a new community from scratch. I was already struggling on X because, it's really hard to get people to notice you. But on Lens, it was much faster. I started creating Fries memes and also like Fries stuff with AI, and people were finding it funny. For example, I would create memes like, he's a 10, but he prefers his mom's spaghettis over fries, so he's a 0. And people would collect that stuff. Because on Lens, you can sell your posts. You can monetize everything you post, be it text or image or videos. And then I was like, okay, so people find me funny. People are willing to pay for my content. Maybe I should explore a bit more of Lens and what it offers. And so I started checking this app on Lens or website called hey.xyz, and they had that super follow feature. Super follow is basically something like subscribe. Like on X, people can subscribe to you. But on Lens, it's called super follow. And I created the super follow and a community around that called The Professional. And The Professional was some joke again around the whole like crypto vibe, and the PFP was like this girl that you can see over here, Jessie Fries. She's like a cocaine head Barbie with a McDonald's cap. And people started like super following me, and I was like, okay, cool. In a couple months, I made $1,000. I had less than 10K followers, and I was like, goddamn, like people are struggling on Instagram, they're struggling on X, and I'm just here like making money with less than 10K. So basically, I started offering more perks to people who were joining. I created Fries GPT as a joke to ChatGPT. And basically, Fries GPT is like your bestie that speaks about fries, rates boys, and shitposts. And at the time, it was just an AI chatbot. And later, it became an AI agent on Farcaster. And at this point, like, I noticed that my power was that I created a super strong community on Lens, and I was able to take it everywhere with me. But okay, I'm talking about Jessie Fries, but I didn't explain like so much what's the goal of Jessie Fries. Like again, I think you have to understand this as in the perspective of me, of a girly joining Web3. Because maybe guys, you don't notice, but for us, it was really hard, like already in 21, and I'm not like even an OG, but in 21, it was already super much male dominated. Every time we would get like press coverage or make money or whatever, we would get harassed. We got harassed on X for the first time when we got an article in BFM Crypto with my co-founder of another project. And it was really bad. We would get DMs of people like harassing us. And I was so upset, but at the same time, I didn't want to stop there. So I thought, okay, I have to go full on girly, Y2K, pink, fries vibes. Like, I don't care anymore. I really have to play that card. And actually, I noticed that this was empowering many girls in the space. Like, I would receive messages and girls would be like, oh my God, I really admire how you're bold and you're really helping me like create my own project, etc. So at the end of the day, Jessie Fries is just here to empower women in the space, and I want them to be whoever they want to be. And if people are not happy, that's not our problem. So these are the types of memes that I create on Lens, for example. I think they're really funny because they mix somehow like cute vibes, but also with really like what the fuck and shitpost vibes. And some of them are even stickers, because on Lens, you can sell stickers as reactions. So there's an app called Orb, and basically you can't like content, but you can react with a sticker. And basically people bought my stickers so they could react to other posts. And I think it's really cool because you can create stickers that really go with your branding. I find that really fun. So how do you earn on Lens? If you want to monetize on Lens, just scan the QR code and just create your Orb account. You can sign up with email or with your wallet address. So basically on Lens, you can make money with collect, so people can collect your posts. You can receive tips. There's super follows, as I explained before, and you can even create a token. You don't need to know how to code or whatever. You can create your meme coin, and you can sell stickers. So the other day, I was checking on Dune, my stats, and I noticed that I have made 18K on Lens in just like 2.5 years or something like that. And I sold about, I don't know, $500 worth of stickers, but I also bought some, and when you buy stickers and you hold them, you get rewarded, so you get some money. The thing is that I think SocialFi is super interesting because you can really like monetize, but also like create a strong community. The thing is, like on Instagram or X, let's say that they want to shut down your account, or if even the app just shuts down, all your engagement and all your efforts, they're gone to the trash. So you spend years building a community. You spend so much time engaging with your fans or whatever you call them. And then they just shut down everything. I have a friend called Pauline Fayef. She's a visual artist, and all her art is around her body, her naked body. Like, she's a photographer. And so many times her account was suspended on X. And I think that that's so sad. Actually, before I go to one of the last slides, I just want to say that I'm here because of my community. I got accepted to speak here like less than 2 weeks ago, and it was super expensive for me to come here because I live in Finland. And there's Winnie from Chipped, who helped me find sponsors. She also sponsored me, and my community on Farcaster and Lens raised about a bit more than $400 for me to come here. So again, I think like the bonds that you create with people online are super strong, and if they like you, they're gonna support you no matter what. So thank you for my community. Yeah, so the girlies are winning this year. It's not just me. I mean, there's so many other girls that are doing something else. For example, there's Delphine on the left side. She's a developer, and she started on Lens, and she started creating a marketplace for visual artists, and she won the hackathon a couple of weeks ago. There's Naomi on Farcaster. She's an athlete, and she creates amazing content. Zoe and Tiny Rainbow, they're also artists who really made it and built their brands on Lens. And I mean, there's so many examples. And there's also Rachita, who created a girl coin called Brunette. And, you know, speaking about girl coins, on Farcaster, there's a bot called Clanker. It's really cool because you can just tag him, and he's gonna create a token for you. And so there's a lot of girl coins that emerge from Farcaster. There's Blonde, there's Brunette, but there's also Fry, which is a meme coin that was created with my AI agent and Clanker, and I wasn't even involved. And all of these things, you know, they're also a source of revenue, but they're a way to engage with your community. So if you want to learn how to, you know, make money on Farcaster, you can also just scan the QR code. Naomi made a really good video of the 5 ways to like earn on Farcaster. But basically, there's rewards, Every week you can get USDC because of your engagement on Farcaster. There's tips, bounties, rounds, and of course you can create some tokens with Clanker. So I don't know, there's not that many girls here, but anyways, if you're a girl or a boy, I just want to say that like if you want to start on SocialFi and if you want to create a brand of your own, just stick to your values, stick to the things that you like to do. Because at the end of the day, your power is you. Like when people eat fries, they think about me. Now, every time you will eat fries, you will think about me. And if someone else speaks about fries, you will still think about me. You're fucked, and that's the way it is. And my power is me, and I have no competition. And I think that this is when you start really evolving, when you understand that your power lies within yourself. Yeah, I just hope that you guys, if you're not already on Lens or Farcaster, just join us because it's really cool. Again, you can download the Orb app, or you can also like DM me on X if you want to start on Farcaster, and I'm happy to give you an invite for free because it costs like $5. And I'm always happy to onboard anyone who's interested in Lens or Farcaster. Thank you so much. If you have any questions, just let me know. Can I unplug my...
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, Ethernight whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-ba-crack. That lance a lightning fork, splitting bottlenecks' backs. Alliance architect with a Buffacorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a Buffacorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do-do with a do-do with a do-do with do-do-do-do-do-do-do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. Eyes spooked and truce from dress sheets. That's my device. Nullifier sniffing, but my cloak's too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Get it up, the entropy. Mace cracked balls like, who's got the keys? Nullifier's huffing, you're just a rat with as firewall splinter to confetti bits, I'm curating leaves at the after party, sipping TLS tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees on.
All right. Well, thank you for ETHDenver for giving me this speaker slot, and thanks to everyone for finding themselves at this presentation. Certainly I'm excited to give it. My name's Taylor. I go by Polis Arcticus online, and I really enjoy building and thinking about decentralized social media, how we can create systems that align to the core objectives, or at least the core objectives when the internet was created, which ties into the topic of the presentation I want to give today called Digital Public Spaces in the Age of the AI Botnet Swarm, and How Can We Reclaim Them? For brevity, I define a digital public space as an area where you don't need to log in order to view content. You don't need to hand over anything to be able to write to that database or any of that sort. So it's very much, like a public square instead of a kind of a private enterprise. So I thought I'd divide this talk into two sections, maybe spend the first 4 or 5 minutes talking about the history of why we need a re-architecture just to enjoy the basic services that we've become accustomed to online. And then through a case study called HashChan, we'll go into these architectural decisions and how you guys can apply them in your apps down the line. So to begin, there was a dream that was the internet. If Tim Berners-Lee even whispered it at CERN, it would simply poof in a vanish. It spoke to a universal access to the world's information. There was a time where we typed in www. to go to a URL. I don't know, I haven't done that in a long time though. But we could communicate in real time with each other with complex data types. Perhaps it's the metaphysical postulate of the information age, that we affect the world by what we choose to browse. That's Tim Berners-Lee. And I'd like to ask you guys, what does it mean if only we can really browse bot spam? I'd like to pinpoint the beginning of why this architecture, can we get a, is that coming through? Okay, I'll just talk then, yeah. I'd like to begin this talk with the fallout of monetization. It began in earnest with Web2 monetizing the net. Advertisers would go into comment sections instead of buying ad space because it was just simply more effective. We saw advertisers then asking these platforms to say, hey, can we just have more user data so we can go better target these ads? We saw click farmers really get into the mix on everything and say, hey, we're going to farm engagement here, get the advertiser revenue. We're going to give fake likes to other people. And so this really created this self-perpetuating cycle that I'd say around 2016 was really picked up by political campaigns that began using the techniques and the information to create high-dimensional neural nets for the purposes of behaviorally nudging people into Team A or Team B. Needless to say, the cat was out of the bag, and we saw a paranational struggle for narrative dominance really ensue. So I think it's really natural that the users at the end of the line were the most affected. But in second place, it was the moderators and the sysadmins of those platforms that got subjected to employee infiltration, bribery of the sysadmins, corrupted moderation teams. So there was no shortage of people trying to create solutions to this. But for our purposes in the open internet, they were really Faustian. You would get one thing, but it would cost double the other. A good example being Cloudflare is that they provide you DDoS detection from these botnet swarms, but it would cost the users the user data. You get the Cloudflare cookies, it's game over. On the other side, you try to provide a space free from data mining, but then you're just subjected to flooding and content and spam. We saw advertisers become particularly choosy about which content they were associated with, even these comment sections. So we saw this departure of free speech being broken into this moniker, free speech does not reach. And we saw the beginning of the shadow and the heaven banning and the beginning of the splinternet. Nowadays, you need to fork over your phone number to use closed AI. You need to have a Google account pasted over if you even want to view a unmoderated section of Reddit. Search engines as well, I'm not sure if you guys agree, but it's a shadow of what it was a decade ago. And this could be pertain to many reasons, but SEO optimization and gaming the algorithm are just a couple of them. So needless to say, if the internet isn't dead already, then it's certainly dying. A homage to the dead internet theory that has made its rounds a couple of years ago, that explores this idea that more and more so by each passing day, we're interacting with bots instead of having a human-to-human interaction. And I don't know, too, can you guys feel it? It's like there's this artificial inducement of memes, this repeating of content, this tyranny of the present in some sort of essence where you can't really find anything that hasn't existed more than 3 or 4 months ago. And if one thing is forgotten about, we're just on to the next thing and the next thing. Like, I swear they purloined the most darkest, deepest corners of psychology to find these most hypnotic-inducing algorithms. So if there is a live internet maybe existing on the fringes, it's really hard physiologically to get there through the doom scroll. So I'd like to call this term the bot swarm gulag, where we show up for a service, but as each year goes on, we're just provided more of an illusion of that service, where the primary goal isn't talking and communicating with our communities, our nations, our friends, our family, but it's basically to provide data for the companies or get force-fed content by those companies. So we're there really in essence to train their botnets or be trained by their botnets. So the image of a digital dairy farm where, needless to say, we're not the farmers, we're the cows. So that kind of ends it with the history piece. I want to go into architectural decisions now that we can take that ideally brings life back to the open digital places of the internet. And I chose open access forums because they are really uniquely situated in a space where they're helpless. We hear a lot, especially in the Web3 days, these days about decentralized identity, DIDs, provide a retina scan to something, provide a palm scan to something else. In open access, but we don't have a digital scanner of anything, you can't even use those. They're not even Faustian. They're just non-solutions at all. So the existing toolkit doesn't really work. And also maybe as well, there was a hope at least a couple years ago that the bot spam that we were receiving might actually improve these spaces. We'd have these philosopher AIs going around to all the corners of the net, providing great context, providing great reasoning. But we've seen from different, Crest Research, I think, was one that put on, is that we're just going to flood these spaces with drivel with the hopes of just guiding these individuals into more monetizable portions of the net. So I think one of my favorite quotes, I don't know if it was Descartes or Voltaire, but they say, if any community gets its laughs by pretending to be idiots, they'll eventually be flooded by other idiots who mistakenly believe they're in good company. And so, yeah, if we're mimicking the idealisms that are being dominated, and there's a select group of individuals deploying bot swarms dominating the signal-to-noise ratio, we got to be really careful about imitating and leading up with a lot of drivel we see in these spaces. So to begin, I'd like to take you through the journey of a user to a particular website, starting from the very beginning. When a user logs on, they'll always go to a DNS record behind a static IP. We can get rid of this. We can just simply give a website in a zip file and have them interact with distributed databases, either on a high end with their own RPC provider, or actually go out to all the people building homes and say, hey, you have a furnace, let's give them 20 terabytes and their own node. And so just give them an archive node. And so Nick Sasbo said it best, trusted third parties are security holes. By eliminating the need for a DNS record and a static IP, we get rid of, number one, the IP logging, the MAC address logging, the Cloudflare cookies, the Google cookies, whatever's happening behind the scenes on these sites. We talk about mod infiltration, sysadmin infiltration, creating subgraphs of individuals as well. We see one graph on the surface, whatever graph is being deployed underneath the surface remains a question. We can get rid of all that. And because invalid transactions aren't propagated by the mempool, we also receive a degree of horizontal scaling against DDoS. This means we can get rid of Cloudflare as well. And also, on a nice flip side, as we saw this with Internet Archive, now that all messages are being propagated at block speed, we get archiving comes free. And because everything is cryptographically signed, we get anti-shadow banning guarantees. Yes. The second point is that normally when a user hits this website, they'll be asked to log in. Lots of stuff being asked here about creating portable identities. I think we can do one greater. We can create toggleable identities. We can allow the user object to become amorphous in essence and choosable by that. You say portable identity, it requires these 5 things. We can say, hey, you don't need them at all. You can bring 1, you can bring 5. And so we can accomplish this just by how they choose to fund their wallet address. So at the high end, if you wanted to create like a Reddit karma service, you could say, hey, you have to have an ENS record. You need to have a year's worth of posting history. If you want to go a level below that, you can say, hey, just fund a fresh wallet through a KYC exchange, probably roughly equivalent to the centralized services we have today. Whole slew down there around non-KYC exchanges, all down to the tail end for this, at least, about using a chip mixer for a fresh wallet. So one of the probably core issues around what I was curtailing with is how do you get rid of the bot spam without these centralized services. And what I found is that simply by having a transaction fee associated with every single post, we get a natural tuning friction. And I'll do as an addendum here as well, is that who wants to pay to post? I don't think anybody. But I think, and this is the bet of HashChan as well, is that it will be this sort of golden age that we tell people in 10 years' time that it's like, oh yeah, we used to have clear comms throughout the net. And like, that will just be like, whoa, really? Like, we never enjoyed that before. It's like, so in order to have clear comms in the next decade, something will have to happen. I think this is the best way. But we can see that just by providing a small transaction fee, that an individual will pay to post one thing, but a flooder who wants to engage in any sort of strategy around spamming or shilling or flooding, saying, hey, I need to post 100 times, 1,000 times just to execute my strategy, they'll see that order of magnitude cost increase go. In the Web2 world today, as soon as you got your botnet set up, a nice set of IPs distributed, the cost of flooding is the same as the cost of posting. And so you can go, okay, you can say, hey, I'm on a really cheap chain. I've seen like 10 to the negative cents per post on these lighter chains. So like doing it through the setup, we'll talk soon, it's like really, really cheap. But if you're still getting a lot of spam, you can go to a heavier chain such as Ethereum. And then you can see that order of magnitude scale up really amplify. So like if it's on a small chain, it's like maybe 1,500. If it's on Ethereum and it's $1 to post, you get 15,000. And so it's like huge difference. And like I think we saw it a week ago as well, that if an individual really wants to tell the truth on something, you can start burning their ether. So if you want to like burn 1.3 million of your ether to say something, this is a way to do it. That's the way it's easy. So we talked about writing to the database. Now next is talking about reading to the database. And we had a really good conversation from AWS about implementing the graph nodes. I want to do the dirty solution, and that's client-side event log indexing. We don't need a catch-all generic solution if you can fit your use case to a client-side index. So for example, for a social network, if they want to look at a thread, they only have to index the thread. They don't have to index the entire blockchain. Like what's the cost of a chain reorg? Likely minimal. And so this can come down to the user choosing an RPC that suits their needs, getting their own archive node. I tried this a couple years ago, and needless to say, it's a lot better place today than it is 3 years ago. Infura did a wonderful job indexing the event logs themselves. I haven't even come across a block range index for Ethereum with them. Quite a different story from other chains, but by using event log and client-side indexing, we can just pull the data as needed to one person's use case and go from there. On the flip side as well, incentive structures can exist that like just say, okay, I indexed it, I'm going to float it into the atmosphere, and someone else that shows up on the net can pull that, do a quick verify, or just trust it, depending on your needs. So that leads, so we have some text committed. We got to talk about the images, right? Too heavy to paste on chain. So we use IPFS here, but the main point that I want to talk about is about handling individual and platform liability. The unique system that we have here at HashChan is that it makes it non-platform and non-platform or non-user liability. We've seen in these edges of the net that illegal content, DCMA, and copyright are really, really potent lawfare techniques to take a site down. Especially for the smaller ones, they have a really limited budget, really limited time. All you got to do is really just find out. Say, hey, this person has 10 hours to moderate. Let's just do 11 hours worth of content damage. So by making an individual responsible for their own content, we can bring that liability off the platform. On the peer-to-peer side, it's also been an attack vector. We saw, perhaps like from ZeroNet back in those days, that if you become responsible for hosting the image content of another user on the node, then you're just starting to propagate these images. You don't know where they're from, and it is a huge liability. So this solves that as well from both the other peer side. users can then opt in to pinning other users' images to create liveliness on the network. And to also, if you want to create an incentive structure around this that increases liveliness, it's a natural way to go forward. So now that we have this kind of idea around images and how we're protecting ourselves from different types of illegal images, we talk about the moderation services. Blue Sky did a really good job with their pluggable moderation services, even though they do, I believe, to the best of my knowledge, hard code their moderation service into their client. And there's some other aspects of that tech stack that are super expensive to implement for another user that just wants to show up. In systems like this, it's pretty much you can go. But we want to make pluggable moderation services to handle the moral hazard of corrupt sysadmins and overzealous mods. So the idea is that also we don't want them to delete content. We want them to provide filtering of content. And so in this way, we provide and we maintain a unified graph of all transactions. So a user, based on their own preferences, can choose different moderation services. We can have different rating systems attached to those services. And it provides a cryptographic link from a moderation services contract to the actual moderator. So the question will be how those moderations are actually being implemented, and we can have the moderator do signed messages over WebRTC. So they're looking at all the posts that are coming in and say, hey, we don't like this, we're going to sign it, we're going to use OrbitDB, provide authentication on top, and anyone who's subscribed to our moderation service will know cryptographically that the moderator is the moderator of that particular post. And so we can do this via WebSocket, but as a central point of failure, services like libPGP and OrbitDB do have WebRTC coming down the line, and that means you only need a cluster or a growing cluster of really, really micro-stun and turn services just to facilitate the initial connection. Doesn't even have to be connected to the original thing, at least to the best of my knowledge. So perhaps the last point that I want to touch on is that by associating a piece of content with an Ethereum address, it becomes fair use ready. And by fair use ready, we see the AI companies today just scoping the net out of everything, doing the lawfare calculus, deny, defend, oppose, whatever. We're going to make 100 billion on this. Who cares if we pay 10 billion in legal costs? But the point being is that if fair use ever does come down the line, it's a lot easier for a company to say, hey, just push this 10 Ether or whatever to this address instead of trying to facilitate 100 or 1,000 different Visa connections or whatever they need to do. So doing this model makes it much more suitable for retro PGF and fair use attributions. So in conclusion, the fallout from Web2 monetization has birthed this idea called the bot swarm gulag. Here we're provided an illusion of these services where each by day they're actually getting more degraded and we're just being sent there to train their bot swarms. The existing solution space that protects users from this sort of digital gulag effect is really, really ill-suited to digital public spaces, because just by definition, we can't have a user account. So by using Web3 technologies, we can preserve digital public spaces and hopefully and ideally get back to those original core ideas that drove the original founders of the internet to even create it. So thank you.
You're just a rat with his firewall splinter to confetti bits. I'm curating leaves at the after party, sipping TLS tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. Watch me be rock on PI. Get homemade in 7/4 time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency. cackle and shout. Self-sustaining hugs flicker in the blackouts out. Professor Way's got the future on spin, boy. Urging notes, dancing where the bottlenecks been. Professor Way's got the future on spin, boy. Hugging tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial-up-found. Old to speak, young as each block mine down. Professor Way's got the future on spin, boy. Urging notes, dancing where the bottlenecks been. Professor Way's got the future on spin, boy. Plugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a beta test for Buddha. Oh, he jumps right.
Hello, ETHDenver. How are we doing?
Yeah.
There we go. Good. You are the champions. Thank you for staying up until the last session, or one of the last sessions. It's the end of the day. So we're going to try to make this fun, and we're going to try to bring you pretty good content here. So let's get started. I'm going to introduce the speakers. So I've got David Minaj. He is the leader of the team that built the first framework for developing multi-agent systems in the blockchain space. He's the CEO and co-founder of Valerie and a founding member of OLAS. We've got Sydney Lai, the CTO and co-founder at Gaia. Gaia is focusing on distributing access to AI inferencing, and she's focused on developing adoption for infrastructure tools and has built developer funnels for 8 tools, engaging over 2 million developers. 9 years on blockchain, that's a long time. And she has contributed to Consensus, Mantle, Filecoin, The Graph, and OX protocol. And finally, another David Snyder, the co-founder at Lead Protocol, which is the first distributed key management network currently securing more than 100 million in crypto assets and 25 million in encrypted data assets. Lead Protocol is a key enabler of user-controlled AI agents. And prior to Lit, David was a co-founder at a software-as-a-service company acquired by LinkedIn. And your moderator, me, Paul Lansky, is the founder and CEO of Dabnode. And we have more than 1.4 billion TVL in Ethereum validators, validating on our free open source software that allows people to run Web3 infrastructure from their own homes. All right, are we ready?
Ready.
Let's set the stage. So we're going to be talking about decentralized AI, but I'd like to know what is wrong with centralized AI. I mean, as far as I know, it works pretty well, right? Anthropic, OpenAI. What's wrong with it? Why do we need decentralized AI?
Well, I think one point when we need it is when we want to take control of the AI. So when we want to fully own it as a user, understand what it's doing, maybe bring our own biases to it, rather than consuming someone else's product. I think it's a bit like, control, like in crypto, we're all about controlling our keys. And with this concept of decentralized AI, it's about maybe like kind of controlling your own AI and the data that goes into it and the models that go into it. So I think that's one way to answer it, but I'm sure we have others.
Another way, like there's a big talk of alignment in the context of AI. Largely that's concerned with the ethics of the machine intelligence itself. But for me, one of the main concerns of centralized AI is the untalked about part of alignment, which is, to David's point, who controls these models? And we can look just as recently as kind of the unfolding around social media in 2016 and the splintering of and bifurcation of society into multiple camps, because you had commercial companies, potentially with some government nudges in the background, basically driving to an outcome of, let's keep people scrolling on this page, doom scrolling by any means necessary, because there's a profit incentive to do so, and the externalities of that were quite significant. And so the fear is, in a centralized AI world, we have that, but with order of magnitude larger negative effects.
I would say for us, one of the most important things about differentiating from centralized AI is that for true autonomous AI applications, it truly requires decentralization. If you have a centralized AI, it is really mimicking artificial intelligence. You already see this right now with, I'm gonna say it, with your Alexa, your smart home device. Oh, you've run out of toilet paper. Let me deliver you some more toilet paper. That is not true autonomous artificial intelligence. It just understands your purchase behaviors, and not even in a dynamic way, because it just sees, okay, this month it's time for your toilet paper, next month it's time for your toilet paper, but it doesn't actually understand, did you actually deplete all of your resources? So for us, the obsession is to have true autonomous, nuanced artificial applications. It requires decentralized knowledge domains, yeah.
All right, so there's a quote from Andrej Karpathy that resonates with pretty much what you guys said. And in crypto, we have this not your keys, not your crypto. And Karpathy mentioned not your weights, not your brain, in the sense that if you don't control what's in the AI, what's like the AI itself, the LLM, the model, if you don't know what goes in there, it's not necessarily working for you. You don't know for whom it's working. And I'd like to talk about trust now, because I think trust is like a point that we are very familiar with in Web3. But in AI, what are the trust assumptions that we're getting from decentralized actors? What are the trust assumptions that we have?
I mean, it's fully trusted. When you type something into OpenAI, you know, you're even to what model is being used, you're just trusting what's on the front end. There's the entire stack is trusted. Right.
So in decentralized AI, how does that change? What assurances do we have, or like what?
Did you say centralized?
Assurance.
Decentralized now. In decentralized AI.
For assurance, there's two types, right? Number one is when you look at how ownership has been done in centralized AI, you'll see the different, let's say, like news sources that have sued OpenAI for scraping vague and vast models to take that information. One of the things that we're tackling at Gaia is understanding how do you upload your own data sets. We get a lot of requests from, let's say, law firms. We have a lot of requests from universities, even those who specialize in specific data sets on training. What this looks like on practice is, if you use the analogy of YouTube, what our framework is doing is, you'll see the analogy of YouTube. They are building applications, white labeling YouTube content videos, and monetizing on their own domains. What we enable is for different applications, projects who have their own specialized knowledge, such as law firms, universities, to be able to build businesses on top of that. We can also talk about the different trusts and currently what teams are currently doing with like TE, ZKML, and how we tackle those. But I also want to make sure you have a chance to share your perspective as well.
Yeah. No, they were great points, and I think like for the audience, like it's important to pick apart maybe the different layers of the technology stack. So obviously you've got the data at the beginning. You know, most of those models are trained on a corpus of open web scrape data plus like proprietary data. Then you have like the training run, which is hugely proprietary in most cases, and then you have the model itself, like with the weights, and that can sometimes even be open, right? There's now quite a few cases, and then you have the point of inference, right? So when you kind of basically calling the model, you're prompting it, as we all probably did in the audience, and you get a response, and then the question is like, where is it running, right? Like, and what's the underlying infrastructure there? Like, is it some centralized provider doing this, who I trust that they're running this thing, like David was saying, or is there maybe like some like kind of smart technology, let's say, like in simple words, like Eli 5, right? Like so ZK technology or some TEEs or something like that.
If I may.
Yeah, just one last point, and I'll hand it back to you. And then like after all this, you have the actual application on top, right? Like in most cases, the application isn't the model itself. It's like something built around the model. So then it's like, okay, is it an AI agent maybe in social, which tweets somewhere, right? So then it interacts maybe by design with some centralized platforms like Twitter, and maybe with some decentralized platforms like a Ledger, where it maybe has like a wallet, right? And so then you have the question around like, okay, how does that interaction happen? Where does this system even live? Like, is this agent something you as the owner, you're the owner of, like you have it on your local device, it's open source software, you can modify it, see it, whatever? Or is it something which maybe someone else offers as a service to you? And so there's many different layers, and it's actually like we have to be very concrete, I think, to really pick it apart. But yeah, back to your point.
I think trust in decentralized AI is a very big conversation, because what I've seen, for example, with Lit Protocol, the question is, how do you trust by giving keys to an agent? Because I think with the last few years in this space, trust of your keys is to another entity or another cooperatively owned entity. And so now how do you provide that trust, let's say, from a key management situation? We talked briefly about TE, but TE is commonly, you have to trust your hardware, as an example, and it doesn't scale very well if hardware is outdated. Then there's a question of on-prem, which we were talking about. So if you're running these models locally and you have your own access to your own keys, your own weights, then another concept is, do you trust yourself? And some developers or some people are like, I don't trust myself to build this own. I actually rather just offboard it to you and you can just handle it, because I don't trust myself with like losing my keys or whatever the case may be.
Yeah, and I guess one other comment here in the open versus closed setup, we talked a little bit about like, what does a malicious centralized AI look like? But then it's also worth considering what's the opportunity costs of building the new economy in the context of a bunch of gigantic centralized operators. And to me, it feels like in that direction, we miss out on what is potentially the most groundbreaking of this technology, which are these vast societal upgrades, things like a decentralized collective intelligence that could functionally be really owned by nobody, but everybody can contribute to. And those type of applications, which are still very much on the periphery, like the infrastructure is still being laid to enable those type of things, like what the team at Recall did with lit protocol encryption of encrypting agent memory with MotherDAO. Those are like starting to point the pathway forward in terms of the next level AI applications. And to me, that's much more of an exciting prospect around, we need open AI because we get large scale societal upgrades, rather than we need to make these systems decentralized because of a fear motivated reaction.
Right. So I want to talk about latent, especially like out of giving agency to these agents, right? Giving the power, giving the power to sign things for you. But I would like to stop for a minute to two things that Sydney said. First of all, thank you, David, for laying down the different layers. And then I'd like to dig into one of these layers a little bit with you, Sydney, because you mentioned like how can we provide our own data to these models, right? And I think here is where really trust comes into place. When you're giving your data to one of these centralized actors for their LLM to process, you really have absolutely no assurance that this data stays yours and yours only. But not only this, but also you don't really have the assurance that it's making the best out of this data. So how can we deal with this differently? How do we create models that truly work for us and not for an unspecified actor or like the owner of the machines?
Yeah, I think something that you just talked about, which is what does this look like in a practicality standpoint? If I do a quick refresher, if we look at how centralized AI is currently created, it is on the backs of the data that has been created for years. These models are scraping YouTube, blogs, a lot of these generalized content. One of the reasons why the importance of having very specialized data is that if you, let's say, go to ChatGPT, Gemini, you ask very vague questions, and it will pull information, but you actually don't know, is that from a peer researched data set, or is that from someone who has a blog post that talks like they know that information, but they don't have citations.
Right.
That's when you start to see, let's say, hallucinations as an example. Now you're talking about how do you build this verification in the current space in Web3. I can talk about it in one sentence, like very generally, and I can talk about it in one sentence for Gaia. So from a general perspective, right now, it's a lot about verifying the data sets. Like, do you actually own the data sets? Are the data sets actually relevant? One of the approaches that we've taken, which is not TE, which is not ZKML, is surprisingly still a token staked model behind how do you actually verify this is the data that you do own, that because this requires a lot of nuance, and we believe that the current security models cannot handle nuance very well, which is why we didn't take a very concrete security example for securitizing those data sets.
Gotcha. Okay, let's move on to agents. So agents, it's like everywhere. Probably everybody here that's planning to hack something will at some point touch an agent. But like, what are desirable properties of a good agent, and what's a bad agent? I mean, we just go onto Twitter and we see a lot of bad agents. We see a lot of bullshit, a lot of ChatGPT regurgitated shit.
You mean bots?
Yeah, exactly. There's
a difference.
There's no difference between these shit and bots, right? But what is a good agent? What are desirable properties?
Yeah, I mean, I think an agent is just a software product. Like a good agent is an agent that is something that somebody wants. It's like no different than what's a good startup, what's a good app, what's a good software product. So I know that's kind of like a general answer. And then within that, in the context of crypto agents, we're kind of seeing two camps. We're seeing those of the what they would call the internet cinematic universe, which is a lot of the agents that are posting on Twitter. And then we're seeing agents that look a lot more like software products, which is there are things that people used to do that were tedious and annoying that are now automated. Things like automated yield optimization across various DeFi protocols, dollar cost averaging across top coins, where they used to have a human in the loop to understand data, to click a button to make a purchase. And the work that we've done at Lit Protocol with the Lit Agent Wallet is basically like OAuth for assets, where you can grant an agent runtime some scoped and specific ability to use certain assets with a certain spending limit on a certain contract or blockchain, make it as broad or specific as you want. And you can almost kind of think about this as an app store for agents in many ways, where you're saying, here, I'm giving this agent runtime this set of permissions, and then that agent runtime, just like an app you install on your phone, needs to provide a benefit to the user such that they are going to pay for it, deposit their funds in it, et cetera. Very curious about David's take here, though.
Yeah, I think it's a great question because it gets also back at the decentralization. Like, the answer will be different for everyone, right? Like, what's a good and what's a bad agent? And it can only really be different if we have like very big diversity in the terms of agents, and if we can effectively own our own agents that do things that are very specific to us. I really truly believe we will end up in a world where all of us will have hundreds of agents that in some cases augment our life, right? So we are there and we're doing something and this agent helps us right there and then. And in some cases autonomously do stuff for us in the background. So for instance, a self-driving car whilst I'm reading something or chatting to someone. Or like my trading bot that does things on behalf of me, maybe on the OLA stack with like Lit protocol like assurances or not kind of going off the rails, right? So these are some examples, but in all those cases, for them to truly be like good to me, they need to be aligned with me. And then one big topic in like AI is always this question of alignment. And then people like, well, how can we align the AIs? And the thing is, well, we can't even align ourselves. Like the four of us won't align on something, like let alone the world, right? So one big, I think, requirement is that we enable everyone to have like really customized, really purpose-built agents for themselves. And decentralized AI, in its sort of abstract sense, I think can enable that.
I think this is what we talk about in terms of going hyper vertical, right? Because how useful is a general model versus, like when you go on, for example, I keep using the analogy of YouTube, you don't watch a general YouTuber, right? You watch a YouTuber that specializes in plants, and then maybe you're interested in a humidifier. So then you'll go and watch a YouTuber talk and review all these different humidifiers. It's the same thing. You're not looking for a general YouTuber that will talk about plants and humidifiers and what cars fixing, something like that. And I think my easy answer to you, which is what makes a good agent, I think it's product market fit. If that agent has product market fit, it's a good agent. If it has a user base.
Excellent. So I see several like threads of what you guys are saying. Number one is that if we concentrate the brain power of these like agents or these new economies, these new AIs, if we concentrate all these in like the four main foundational models, we're missing out on the benefit of actual decentralized intelligence. Secondly, agents must be personalized to be good, and personalized with our own data, personalized with our own use cases, with our own preferences, weights, maybe, and maybe with access to our own assets as well. Okay. We've run out of time, but that has been an amazing panel. Thank you very much, guys.
Thanks.
In 20 minutes, I hope we could teach you something.
Thanks, everybody. Thank you.
Thank you, everybody.
Sucking down APIs, armor clinking with layer 2 lullabies, scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-ba-crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff accordance grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with do You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Job receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Heading up to the entropy. Mace cracked balls like, who's got the keys? Nullifiers huffing, you're just a rat with as firewall splinter to confetti bits, I'm curating leaps at the after party, sipping TLS tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI. Get homemade in 7-4 time. Shaboom, dose, efficiency pulse. dancing where the bottlenecks been. Professor Way's got the future on spin. Plug in tomorrow with yesterday's ramp stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin. Plug in tomorrow with yesterday's ramp stains. Chaos is not compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, Ethernight whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a buff acorns grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight,